Welcome to episode 179 of the Arc Junkies Podcast. I am your host, Jason Becker. So a while back, my buddies Brandon Parrott and Peyton Evans of DUM Welder told me I should reach out to their former welding instructor, ScottieSmith. Now, Scottie is a Navy veteran welder and a second-generation welding instructor. His father was actually his welding instructor back in the day, and Scottie learned a lot from him on how to train welders and prepare them for the workforce. Scottie's also written a book called How I Teach Welding, and it's available on Amazon right now. Today we talk about his welding journey and some of the similarities and differences between our programs and our teaching strategies. It's a great episode for any new welding instructor or anyone currently looking to add something new to their current program. But before we get into the show, I got to tell you about some of the great products and deals from the sponsors of the show. Today's episode is brought to you by Fronius USA, and right now they have a special deal for listeners of the Arc Junkies Podcast. But you gotta hurry, this deal only lasts till the end of June. Right now, when you buy any Trans-Steel 2200 welding machine, it comes with a free rolling hard case. It's a $200 value. This is a perfect machine for mobile welding. Just put the machine and the accessories in the hard case and set the case in the back of your truck or your car, and you're off to the next job. It'll even operate on up to 300 feet of extension cords without a drop in power. The best part is, the Trans-Steel 2200 is a 3-in-1 multi-process machine, so you can run stick, MIG, and TIG off a single unit. And if you get the aluminum consumables package that's purchased separately, you can even run MIG aluminum. And it only weighs 34.17 pounds. This is a great machine for mobile repairs such as restaurants and bar work, sanitary piping, maritime fabrication and repairs for stainless tubing and other miscellaneous on-site repairs and fabrication. The sky's the limit with this machine. Now's the best time to get a great multi-process machine and get to work starting up on your own business. Just go to shopweldingsupplies.com/ArcJunkies and put the Trans-Steel 2200 in the hard case in your cart and use Arc Junkies in the discount box at checkout, and the case is yours for free. And guess what? They also offer free shipping, but you gotta hurry. This offer ends June 30th. We're also brought to you by Rockmount Research and Alloys. Check them out today at rockmountwelding.com. They have all the consumables, electrodes, rods, wires, bits, and blades you need for mobile welding and field repairs on heavy equipment. Whether it's hard-facing, industrial repairs, cast irons and cast steels, dissimilar metals, and much more. Get the job done right the first time with Rockmount. We all know that time is money, and when your equipment is down, it's costing you money instead of making it. Quit putting Band-Aids on your repair and limping your equipment through to the next job. Get it done right the first time, every time with Rockmount. They have a rod for every situation. These rods and wires were specifically designed for the worst case scenarios and still provide the highest quality and reliable welds. They can weld through paint, rust, grease, oil, and other hydrocarbons without contaminating the weld. Try that with your 7018. Not gonna work. Rockmount rods are specifically designed to fix things the right way under the toughest, most unpredictable conditions, because that's the situation you're gonna find yourself in when you're out in the field. Whether you're hard-facing buckets and blades, or rock-crushing equipment, welding a cracked arm on an excavator, or surfacing worn-down shafts, augers, or teeth, Rockmount has what you need. Check out their website today, rockmountwelding.com, or give them a call at 1-800-272-7637 and tell them the Arc Junkie sent you. We're also brought to you by Everlast Welders. They have a machine for every project and every budget. Whether you're just getting into welding as a hobby or you're a seasoned professional, Everlast has some great performing machines and they're very affordable. You can check out their full line of multi-process machines, plasma cutters, and generators today at everlastwelders.com. I personally own two of their machines, the 255 EXT and the Cyclone 200E. Between these two machines, I can knock out anything that comes through my door for my side business. Both of these machines have paid for themselves in just a few months, which is great if you're starting a small business because Everlast even offers financing on some of their machines. They also have a 5-year warranty and a 30-day satisfaction guarantee. That's right, you can try out an Everlast risk-free for 30 days. And if you buy any machine that comes with a stock foot pedal, you can use Arc Junkies in the comment section at checkout and get a free Nova foot pedal and TIG torch absolutely free. That's a $100 value. In addition, they also have the new Nova Bluetooth foot pedal that is compatible with most other brands of welding machines. And right now, they're available for the low price at $329. That's less than half the cost of other wireless foot pedals on the market. Stop by everlastwelders.com today and check out what they have to offer. Are you going to FabTech in Chicago this September? If so, stop by and check out the live Arc Junkies podcast at the AWS booth Monday, Tuesday, and Wednesday, 30 minutes after the show starts. I've got some really great guests lined up, and we'll even have a meet and greet right after the show. I'll be co-hosting the Arcs and Ales event with Stephanie Hoffman at the Northman Beer Garden on Tuesday evening, September 14th. Stop by and grab a beer. I'll drop a link to RSVP in the show notes of this episode. All right, y'all know what time it is. Fire your machines, drop your hood, and turn me up 5.
You're listening to the ARC Junkies Podcast. Helping you make every weld better than your last with each episode. And now your host, Jason Becker.
All right, so ScottieSmith, we have a mutual friend, Brandon Parrott, has been telling me about you, as well as Peyton Evans, my buddies over there with Some Dumb Welder Apparel.
Yep.
They're like, man, you got to talk to our welding instructor. And I've been wanting to do this for a year, and they were telling me, he's like, oh, yeah, he's got a book out and everything. And so I'm not a big fan of reading whatsoever. I mean, unless it's like pictures.
I'm with you. I understand completely.
But I actually bought your book on Amazon.
Oh, wow.
So
thanks.
I read it last year, and then I read it again this year, and this is actually something that I'm going to give to my welding instructors. The funny thing is like, probably, like the first 30 pages that I was reading into it, I was like, damn, it's like I'm reading, my autobiography. Other than the fact that you were in the Navy, I was in the Marines, but, I mean, yeah. Well, we can come to a common ground on that.
Yeah, I think so.
But yeah, just the way you lay out your classroom, the way you lay out your lab, the no bullshit policy, I really like that, and it's good to see other instructors doing that, because one of the problems I have is, like, as a welding educator, and you probably get this all the time, you get students coming in from other schools, they've spent a ridiculous amount of money somewhere else, didn't get the training, they're run through kind of like a puppy mill, but you actually care about what you do, and you're actually the second generation welding instructor, so your dad was a welding instructor as well.
Yeah, my dad was a welding instructor, and he was my welding instructor. So actually, my father was a welder. I mean, when he got out of high school, went to trade school. And so he's been a welder all my life. And when I was 5 years old, I was outside in the garage helping my dad weld. So I've been around welding literally all my life. And so then, of course, grew up, high school, did the community college route, and didn't work out well for me. So my dad had a conversation with me one day and said, boy, you either get a job or get serious about school. And I'm like, I'll go in the Navy. He looked at me and said, you need a ride to the recruiter, boy. So went in the Navy, learned to weld in the Navy. I was a welder there, came back and got out of the Navy, came back home. And I wanted to get the formal education, the formal training to have, because in the military, you got military certs, military paperwork, but it doesn't mean a whole lot in civilian world. So I wanted that civilian training, and my dad was my welding instructor. And so I did that and went out on the road for a bit. And then when he retired, I was fortunate enough, I applied for and got the position he had. It actually took 2 full-time welding instructors to fill his spot. That's we call him the legend, because he was just so good at what he did, so passionate about what he did. It took 2 full-time instructors to take his spot. So a lot of what I do as an instructor, I learned from watching my dad as a student. And then when I went to be an instructor, I took what he did that I liked and I built upon it. And then I remembered what it was like as a student, and go, what can I do to make it better for the students? And that's some of the things I come up with that I changed and built on what he did and didn't do. So,
when you went through the Navy, did you train at Aberdeen Proving Grounds?
I was in Philadelphia. My A school was in Philadelphia, Pennsylvania. And then I went through second school in San Diego. So I just went through the A schools in Philadelphia.
Okay. I was just wondering, because I went through MOS school back in 2001, and we trained at Aberdeen, Maryland with all the different branches. So it was like Army, Marines, Navy, Air Force, and Coast Guard all in one area to go through. But it was more like a welding engineering type. Well, not engineering, but we fell under the engineering, that job description or whatever.
Yeah. What year was that you went through there?
2001.
I went through in 91.
Oh, okay. That's probably why. So they've since moved it to Virginia now. I guess the welding school for all the different branches, now it's in like Virginia. I heard
they done some change and moved some stuff around. Yeah, it's not like you said, it's all combined now, and it's not in Philadelphia.
Right. So what did you weld on in the Navy?
My very first ship, I was on 2 different ships. The first ship was a submarine tender in which the submarines would come into port in San Diego and we would make repairs to them. So I have welded on nuclear fast attack submarines. And that's all I can really tell you about that because I can't tell you any more detail.
Well, I mean, usually that's really all you need to put on a resume and you got the job.
And I do. I put on there Navy nuclear fast attack submarines. Like, wow.
Yeah, well, tell me a little bit more about that. I can't. It's classified. Done deal, man.
I can tell you. I have to get you.
Yeah, done deal. So what was it that brought you back into education? Like once you got out of the Navy, what was it that, pushed you into welding education?
Well, I said, when I went in the Navy, I wanted to be a pilot. And they said, if you have glasses, wear contacts, you can't do it. I said, okay, well, I want to be a welder like my dad. So from pretty much that point forward, I decided I was going to be in welding. I said, again, my dad's my hero. I followed him. So I got out of the Navy, got my training, and then actually went on the road for a bit. I was in steam fitter, pipe fitters union, traveling the road doing that. So welding just became my career, and I love it. I absolutely love to weld. You flip the hood down, and the world goes away, and just watch that puddle, and you putting those 2 pieces of metal together, and it's just magic to me, and I love it. And so then when I got the opportunity to share that with other people, that's what I love. And I actually did a little bit of, I guess you'd say, training on the road, get those fresh welders coming in, because I had the experience in the Navy and then a couple of years on the road. And then you had the guys coming out of school, fresh to the industry, kind of take them underneath my wing and kind of help them along and show them the ropes and teach them the little tricks of welding in the field. Because welding in a school in a booth and welding on a job site, 2 totally different things. So, and I guess that's where I kind of started wanting to do the whole teaching and stuff, was actually started doing a little mentoring with some people out on the road. So, but yeah, I just love welding. And I know I'm weird, but I weld to relax. Whenever I get all tight and bent, I give me a piece of pipe, run me some beads, just relieve the stress.
Now, see, the funny thing is you described it the same way I typically describe it to people is, okay, you've, like when you put the hood down, everything else goes away. And it's just you and that little molten ball of metal.
Yep.
And you're sitting there manipulating. It's I find it very therapeutic.
Oh, absolutely.
So it's hard for me to stress out. Like when I'm fabricating, I get stressed out easy. Things aren't fitting, or you cut it 3 times, it's still too short. You're trying to put things together. But like once it's all fit up and ready to go and you put a couple tack welds on there, that's when it's like, boom. Now, once that hood goes down, it's like I'm in my zone. Everything else tunes out. I'll put some music on and just kind of go to the beat. And I've found that it's very relaxing. I've seen other students that, they come in all tense and wound up and everything like an 8-day clock, and, get them in the booth, put the hood down, and they start focusing on what they're doing, and they start calming down.
Yep.
It's like a moth to a flame, man.
It is. And the people that get it, and you probably have those students that fight it. And I'm like, if you would just get out of your way, relax, let it happen, and it'll come to you. And they're like, oh, no, I got to have it. I got to get it. You're too tight. You're too tense. We got to relax. And that's one thing a lot of people don't think understand. Welding is finesse.
Yes.
It's just you finesse. You got to relax and just calm down and let it come to you.
I get them in the booth and they lock up and they get real rigid. And it's like, you can't do that. You got to, my buddy Val said it best. He's like with the pipe fitters union down here in Orlando. He's like, welding, and he's a pretty big dude, but he's like, welding's all about feelings. He's like, you got to be able to feel what you're doing. And I was like, oh, okay, those feelings. Okay, because I don't have the other ones, but tactile feedback, I get that. So that's kind of what I explain to my students. Is like, you've got to finesse it in there. Like you can't hold on to that stinger and choke it like it owes you money. Relax. So I'll grab their hands and be like, just shake their hands a little bit, and just relax, and then grab that stinger and just kind of guide them through, or have them just put your hand on the back of my hand. This is what it should feel like. Okay. Yeah. And then same thing, we're standing in the booth. And I say, okay, grab the stinger out of my hand, and they just pull it out nice and easy. Say, that's how hard I'm holding that stinger. There's like no tension. I'm just holding it enough to where it doesn't fall on the floor, and I'm not pressing it or forcing it one way or the other. It's just flowing.
Yep. I do the same thing. They'll be welding. Like, I'm going to put my hand on yours, relax, and just let me do it. And you just kind of, the feel of it. Like I said, you got to have that feel for it. And I show them the same thing whenever I'm holding stinger. I use 3 fingers, my thumb and 2 fingers. If you got more than that on it, you're going to squeeze it. And just, yes, you got to be relaxed, nice loose grip. And I'm still like you, I got them and show them this is the feel, this is the speed, the angle. Oh, okay, I got it now. And then, of course, step out and they go back to what they were doing before. But,
yeah, that's another thing. When I was reading your book, I was like, okay, you do the same trick I do. It's like, I won't walk into their booth unless they're welding. Mm-hmm. Because like if you're standing there and you're like, all right, go ahead, light up, run a bead, they'll do everything perfect. If they're running stick, the arc length is nice and tight. The angle's perfect, the travel speed's just right where everything's right where it needs to be, and they come out with a good weld. And you're like, all right, cool. And then you go to the next booth, you come back, and it looks like hammered dog shit. And it's like, what happened? So if you sneak in the booth, you can watch them in their natural habitat, and you can catch all their bad habits and be like, hey, look, you're not focusing on the ABCs of welding. Like, always be comfortable. And then you got your, just make sure all your settings are dialed in. Make sure, you've got the position of the electrode, your work angle, travel speed, figure that stuff out.
Yep. And I tell them the same thing. You got to be as comfortable as possible. If you're not comfortable and if you can't see it, you can't weld.
Yeah. If you can't see it, stop welding.
Yep, exactly. I was trying to push it, go around a little bit more. Like, if you can't see where you're going, you're going to run off. And that's why you're halfway across the plate.
Yeah.
I wonder what was happening. I said, you got to be able to see it. And sometimes you got to get a mirror if you're on the job site. You got to be able to get a mirror and do it. But yeah, you got to be comfortable. You got to see it, and you got to relax.
Yeah, I get them in there with gas metal arc welding. They'll be doing like a test plate because we'll run pulse to do our 3G test plates, and they get about halfway up, and all of a sudden they can't see. It's because I was like, okay, you see, look what you've got going on here. Like, you can't really see your puddle. You're just going through the motions. So you're not tying into the sides. You're not breaking down, the face of that bevel. And it's because you can't see it because, your nozzle's 5/8 diameter and your puddle's your gas opening's 5/8 diameter. Your nozzle's 3/4 of an inch and your puddle's 3/8. So the puddle's half the size of that nozzle that's blocking your view. You get above it. I mean, if you need to step, like in our booth, we got very similar setup to you where you can slide down the piece and everything.
Yeah.
And my buddy Ryan Eubank said this, he said it ideally, you got to keep that plate in between navel to nipple, right in that midsection. Because once it gets up, in face level, you're going to cover everything up. You're not going to be able to see it.
Yep.
So like I stand over top of the plate. If I want to be able to look down, check out my contact tip to work distance or my arc length, and then I can check out my travel speed. I can make sure I'm tying into the sidewalls. I'm getting proper fusion. Everything's flowing. You got to be able to see what you're doing. And if you can't, stop and reposition.
Yeah, like I said, you got to get an overview of it, and if you go along, you see how you make adjustments on the fly, and you ain't got to. And a lot of students will try to just use the feel of it and go, "Oh, I think I'm going the same all the way up," or that, and you can't. Like I said, you got to be able to see it. And I tell my students, we have there's a batter's box, we have a welder's box, from your nipples, your width of your shoulders. And I used to tell them about nose to eye height. That box is where you want it to be at, and if it's in that box, you should be able to see it. Especially 2G and 2F and 3G and that type of stuff. But yeah, you got to be able to see where the puddle's going, make sure everything's tying in, and especially on gas tungsten arc welded TIG, if that arc starts to turn blue, you're about to dip it, so you want to back out of there. But again, if you can't see it, you can't weld it. And to get them to teach someone that to position themselves where they're comfortable, they can see it and understand all the mechanics of it, so that then they can relax and understand the artistic side of it, especially in that TIG. You're walking the cup, watching the puddle, flowing it, and make sure it's going up on those bevels, tying into that metal. And it's beautiful when it's great, and when it's bad, it's horrible.
Yeah. So what's your favorite part about teaching? Because I know it's not the money and it's not the fame.
I think my favorite part is when a student that's graduated comes back 6 months to a year later, and they've changed their financial situation. It's changed their life. They used to come back with a new truck and that type of stuff, but they come back, and I know they have the skills I was able to teach them, they used as a tool to better their life. And I tell my students first day, our welding program, a quality welding program, is a life-altering event. You're used to making, working your part-time job or whatever weekend job, making $200, $300 a week. You become a construction welder, professional welder. You're looking at anywhere from $1,000 to $2,000 a week, and that's going to change your life. And to see them come back to the program, talk to the students that are there, and to see that change, and they're financially successful, they're happy, they've paid off the debt, they're helping their family out, and it has changed their life in a positive manner. And to know that I was able to be a part of that. And I'm sure your students probably do you. Oh, thank you so much for what you've done for me. And like, I didn't do anything but open the shop. I showed you a few tricks. You're the one that stood in that weld booth hour after hour practicing it. You deserve the credit. I would just guided you through the process.
Yep. But, yeah. If it was up to me, they'd all be success stories. But we know that that's not the case. You're going to get in, what you put in. You're going to get out what you put in. And a lot of people, they don't want to put in the effort and the time and what it takes because welding's hot and it's, there's sparks and there's flames and, stuff's sharp. And man, this is a lot more like work than I anticipated. It looked, it looked so much cooler on the Discovery Channel. But now that I'm in here, this shit's really hot.
Yeah. And especially you're in Florida like I am, you get in July and August and it's really hot. You're standing in the weld booth still sweating and I didn't plan on this. I'm like, well, this is it. This is actually the nice part of it because you can go stand in front of a fan and get a drink of water. You're on a job site in California and it's 103 degrees, which I've done. You can't get away from it. So the physicality of the process eliminates a lot of people. But I'd rather them learn in a school setting in that transition period than go out there and spend the 18 months, whatever it is, and then go out on a job and then realize they didn't want it. It's not for them. And they've, I hate to say wasted, but the resources that they had for school are used up for something they don't want to do. So I'm sure and what you're telling me, you do the same thing. I try to make the program as much like a job as possible so that they get used to that mindset. So when they go on a job, they understand what's expected of them and they'll be successful. The ones that are able to graduate.
100%.
But yeah, it's not easy. That's why they pay what they pay to be a welder because it's not easy. And any skilled trade like that, anything worth having, you've got to practice it and you've got to sacrifice for it. I mean, professional athletes, everybody looks at all the money they make, but how many hours upon hours have they sacrificed and practiced and sweated? And welders and skilled trades are the same way. You got to sacrifice for it.
Yeah. And that's one thing we actually started doing because I try to run my shop like a job, like it's an employer. And one of the things we implemented last term was we put a time clock in there. So when the students come in the morning, they got to punch in. When they leave at the end of the day, they got to punch out. So I'm trying to develop more and more things. The next thing I want to do is like a job board and have the students, here's your name and here's today's task. You got to go up there and grab the part, the component. There's a blueprint on there. Go cut out the material. This is due at the end of the day, and start grading them on that. Cause I want to shift more. Cause I like the fact that you mentioned that in your book, like train to what your strengths are. So if you're not a fabricator, don't teach fabrication. If you're not a pipe welder, don't teach pipe. That's one of the reasons I don't teach pipe welding in my program. I'm going to hire somebody that knows how to do that and has been doing it for years. They have the experience. They can teach the pipe program or the pipe portion of it. But I'll stick to fabrication and structural and ornamental stuff. So one of the things we're shifting towards is project-based learning. Yeah. So once you get like the fundamentals, the basics of how to do the different welding processes, we're going to have little projects and stuff, like a blueprint with weld symbols and dimensions and all that stuff on there and set up just like real life and actually leave out little parts and components and dimensions so that you have to do an RFI or you have to find that shop foreman and be like, hey, there's this dimension's missing or, where is this a blind hole or is it a through hole? The weld symbol is completely jacked up. What do I do in this situation? And kind of set them up for the same stuff they're going to be dealing with. But, kind of give them a grade based off of were you able to follow the print? Did you stay in tolerances? Did you meet the time deadline?
Oh, yeah. And that's the one thing I mentioned at one point about when we do a weld test in the week, we give them a time limit just so that they understand when you do something, there is a time limit. There's a schedule. And our weld practices during the week are set up on a schedule. And you've got to be ready to take that weld test at the end of the week because every project I've been on and anything I fabricated, there's a deadline. The customer wants this done or wants this product on this date. They don't want to hear that you didn't feel good or that you didn't quite understand or took a little long. They expect their product to be delivered on time because that's what they're paying for. So I'm like you got to get that mindset in school and you're going to encounter problems like you're talking about, hey, the print's not right. This is missing. What do I do? We do something similar, but a little bit different. We do weld procedures. We have AWS digital library and we actually printed off some weld procedures and we omitted some information. And so we have 3 different stages. So the first worksheet, if you will, is just some minor stuff to teach them how to read the weld procedure. And then they have to find it and answer it. And then the next stage, we take even more stuff out to where by the third one, they're actually filling in half to 3/4 of a weld procedure. So they've actually read over weld procedure multiple times and can fill in some missing information or know how to look up the missing information from the code books and that type of stuff. So when they go out there and they got to do a weld test or do a weld on a project and they go, well, what's the weld procedure? And somebody hands it to them. They know how to read it and they got to depend on a foreman. Oh, well, you weld it like this, and the foreman didn't understand. And so now they made a weld with the wrong weld process, the wrong welding wire or stick rod, and they got to cut it out. And now they're getting fired because they got to cut out.
Yeah.
So we kind of do the same thing again. A project, we do a worksheet on the WPS. You got to learn how to fill it in. And critical thinking. You got to learn to think. You know, your foreman is not going to be there to give you every little bit of information because they don't have time. Mm-hmm. When you see an issue, like on your project, you see an issue, hey, what is this? What can I do? And if you can't answer it, then you know to go get some help. You just got to learn how to think for yourself and solve problems. And not a lot of people are learning that at an early age. Mm-hmm. So it's something we have to, as educators, we got to build into our programs.
For sure. Now, let me ask you this question. Do you ever sabotage your students' machines?
No, I would never purposely put electrical tape over the digital displays and then turn their machines all the way up or all the way down. No, that would be so wrong. Absolutely, I do that. Now, I don't do it while they're welding. I usually do it before the day starts. But I got a lab assistant, Scott Bennett. He helps me out. He's really a second instructor. We'll go through, because we have digital machines. So we'll put electrical tape over the displays and we'll jack them up. We'll turn everything up, down. We'll swap leads and stuff and swap the knobs for processes. And they got to figure it out. What happened to my machine? I'm like, night crew was in here. They messed it up. Got to blame night crew for everything. So now what are you going to do?
I do the same thing. I'll go in there like before class gets started in the morning. I used to go in there and switch the polarities. First thing in the morning, switch the polarities. Or when we get into gas tungsten arc welding, because now we have 2 bottles in every booth. So I got 75-25 and a bottle of 100% argon because typically when my level 2 advanced class is on TIG, my other students from the level 1 entry level class, they're on, either short circuit or pulse spray MIG. So I'll go in there and just, hook the wrong bottle up to it. So they'll turn it on. Well, obviously, you got, the shielding gas isn't right, that you're using, and you obviously never checked your flow, which is something else you're supposed to do. So these are the things, and when they run into problems, I train them to start at the cord end of the machine where it plugs into the wall. Okay, that's step 1. Make sure you got a secure connection there and just start working your way forward. Check your gas lines all the way through. Make sure your feeders are right. Make sure all the parts, components are in place, all the way till you get to the end of that torch or that gun.
Yeah, and that's the same thing. We teach a process of troubleshooting because, again, you're out there in a job or on shop, you may be the only one. You got to solve the issue. So they got to have a process of how do I do it? Yes, start here, work your way through it, and know and that's the thing on education. But they got to know what to check. So all right, I'm on MIG. So, okay, do I have is my wire the same size as my contact tip? Is my gun secure? If I got this connected, and then if it's TIG, okay, is it the polarity? So they got to understand the processes enough to where they can troubleshoot them. And one thing I love to do is I can always tell when somebody's welding with 7018 and the polarity is reversed, or it's on straight polarity. You can hear that crackling, and I'll walk up to them. It's running a little funny, isn't it? Yeah, I don't know what's wrong with this welding rod. It's just, it must have gotten wet. I said, we'll try another one. It's doing the same thing. I said, maybe something's not right with the equipment. Did you check it this morning? No, I just turned it on and started welding. I said, well, why don't you check your equipment? Oh, okay. Come on, people. Do your checks every morning. Make sure it's good to go because every day somebody's going to touch that machine. Something's going to happen. And before you strike up on that weld, you got to make sure everything's right or you're going to have a bad weld that you got to do a repair on. Mm-hmm. Take the time because you're going to spend it one way or the other. Take the time beginning, check your stuff, make sure it's right, go through the process, and you'll save yourself time in the end.
Yeah, that's the thing that they don't get until they start running into those problems. Because I have the same thing, man. I can just walk through the shop and be like, oh, that noise is coming from booth number 3, and just walk in there and be like, hey, does that sound funny to you? Yeah, I don't know what it is. Did you same thing? Did you hook your machine up this morning? Well, no, I just turned it on and started welding. Well, how about shut it off, disconnect everything, and put it back together the way you know how, and tell me what was wrong with it. And they'll go through it, and as soon as they get to the 2 leads, man, they're like, oh, shit. Yeah, right there. You identify that sound. So I actually take a day. So within the first 3 days, I start them off on weld pads. So we'll just give them a 6x6 by 3/8 plate We're just going to do surfacing welds, work on layering, work on, getting 50% overlap, make sure you don't have any undercut, just teach you how to run a straight bead. Well, probably by the second or third day, I tell everybody, all right, put your machines on DC negative. And you're going to weld like that all day because I want you to burn that sound into your brain. That's the same reason I don't allow them to have headphones, Bluetooth speakers or, their cell phones inside their booth. I don't want you jamming out. That now's not the, well, I weld better when I listen to music. The hell you do. You don't know any of this, right? You just started welding. I mean, if that's all the better you can do with music, I mean, music's not, it's not helping you. So, but I don't allow them to have that, that way when they're welding, they can hear, oh shit, the MIG gun sounds a little off. Well, maybe I don't have my shielding gas on, or this welding rod sounds a little bit funny. Okay, your polarity might be off, or I'm trying to run this TIG on some stainless steel and it's just buzzing and the tungsten looks funny. Okay, well, yeah, maybe you're on AC. So there's a lot of things you got to be able to hear, smell, and all that stuff. I can walk through my shop and just take a whiff of the air and tell you, okay, this guy over here is burning 6011. This kid over here is, ran out of freaking padding on his Zerk wheel 20 minutes ago, and that thing's just smoking. Like, you start developing these different smells, and you could, tell where everybody's screwing up just by hearing or smelling it.
Oh, yeah, absolutely. Absolutely. And I'm the same way as far as hearing. To me, that's one of the senses you have to use when you're welding because you want to hear that crackle, that bacon in the frying pan sound. Or if you're, like I said, on MIG, if it's popping or something, to make adjustments. So I'm with you. I think sound is an important part of welding, and I don't let them, I'm like you, I don't allow cell phones in the weld shop, no headphones, nothing like that. Earplugs, yes, because grinding and everything is a loud environment, but they need to be able to understand the sounds and what that sound means. And that can help you diagnose what the problem is if you're having a problem, or tell you it's going right. And if you got any crackling or sparking when you're TIG welding, obviously that's not the sound you want to have.
Yeah. So now, in addition to your welding, how long is your program?
We're 18 months. We're in the state of Florida, just like you. So we have the welding technology certificate, and we do the advanced welding as well. So we have daytime and nighttime programs. Our daytime's a little bit faster because we go Monday through Friday, 7:15 to 3 p.m. So we do 35 hours a week of training during the daytime. At night, they're getting 25 to 30, depending on the semester. So if someone starts in the daytime in fall, come out of high school and they start in August, and we go the summertime as well. So they will graduate with the both certificates in December of the next year. Okay. So yeah, we try to. It's a I won't say fast-paced program, but it's a pretty quick program. Because like I said, 35 hours a week. And that's when I tell them, I treat it like a job because it is my job. Yeah. So you need to treat it like a job. 7:15 every morning, I call roll. I don't have tardies. If you can't get to work on time, if you can't get to school on time, then don't bother coming in. And if you miss more than 10% of your scheduled time, then you're out of the program for excessive absenteeism, which is about six days for a fall and spring semester. So if there's a wreck on the interstate and you're late, hate it for you. Turn around and go home. Because I'm there at 30 minutes before school starts, and my students expect me to be ready to teach them to weld. Well, I expect the same of my students. I expect you to be there ready to learn. And you staying out late at night, working or whatever it is you're doing is not an excuse. Well, I was kind of tired, so I thought I'd come in a little late. No, employers don't want that. They're paying you to be there on time, do your job, do it right and safely, and go home at the end of the day. And I'm going to teach you the same thing. If you can't be in my class or be in the class at 7:15 when I call roll, then don't bother coming in, because you're obviously not serious about it. You need to check your priorities and see what's going on in your life. And if you need to make some adjustments, adjust your program, adjust your life, because our program, again, life-altering event. You have the opportunity to learn a skill that's a career, not a job where you're making $1,000, $2,000 a week, depending on how you go in your career. So, we got 18 months, roughly 18 calendar months. Like I said, the nighttime program takes a few more months because it's a little bit slower. Just can't get quite as many hours in. But our college, where I'm at now, Northwest Florida State College, they have been very supportive, and they have really helped me develop this, because I started the program. And I got here in 2013, and it was a Department of Labor grant, and they had not had welding since the early 80s. So I walked in a very unique situation. It's one of the reasons I was intrigued by this job. I walked in and they asked me what building I wanted to put the welding shop in. There was nothing. There was nothing but a pot of money, and go build it. And I'm like, okay. I'm like, oh, how much? They say, oh yeah, you got like $500,000 to equip this thing. So just, what do you want? I got a pencil of paper and started making the dream list of what I wanted. And so we got it built in 2013, started off that fall, and we had 15 weld booths, and just been growing from then. Now we're at 30 weld booths. We got a nighttime program now. We just opened a program at the campus in the next county over. It's got 20 weld booths over there. So it's been growing steady. So we've been real fortunate, especially in our area. We're at around Fort Walton Beach, a lot of tourists, tourist attraction, a lot of service industry. So getting the word out about welding and the industrial trades and trying to get the high school students to realize that a traditional college 4-year degree is not the only option to have a career, and to look at some other stuff and look at, skilled trades, plumbing, welding, millwright, pipe fitting, carpentry, that type of stuff. But it's sometimes it's a hard sell because everybody sees in the service industry during the summertime, them people in restaurants, the tourists, they're knocking out some big money, but then you're about to starve to death in the winter. Yeah. Well, with skilled trades welding, you kind of a lot more steady than that. But yeah, we had the 2 certificates like you do and do the 18 months pretty much. How long did y'all wind up? You said, do y'all do an advanced program? Because you said you kind of bring somebody in for that.
Yeah, we do level 1 and level 2. So so our level 1 is basically the first half of the Florida PSAV program. So it's 525 hours because the total is 1,050. So our first level covers all the stick welding, MIG welding, oxy-fuel cutting, carbon arc cutting, plasma arc cutting, weld symbol interpretation, blueprints, safety, all that good stuff. And then we get into level 2 for another 525 hours. So that's all of our flux core, self-shielded and gas shielded, aluminum MIG welding with a spool gun and a push pole. And then we get into gas tungsten arc welding for steel, stainless, and aluminum, and then a little bit of the CNC plasma cutter. Lately, I'm starting to push more fabrication in there because that's what a lot of the employers in our area are looking for. They need people that can obviously read a tape measure, but be able to grab a print and start putting something together unsupervised for the most part. Coming right into the program, or coming right into employment, they need them to be able to read blueprints and weld symbols. So that's kind of one of the things we're pushing now is we've got some new fab tables in. We just got a new grant into the program, so we dropped about $125,000 in our original facility. And we're also building a new facility. But I do want to put that, we're going to call it like a level 3 advanced welding, and that's the 750-hour pipe course. Because I'm slowly getting more employers asking for pipe welding. So I started welding in 2014, and I think I ran across 2 companies that are looking for one person here or there, but they got to have 5 to 7 years of welding experience. It's like, well, if you know they need 5 to 7 years of experience, why are you calling a school?
Yeah.
Do you want a student that you can teach, or do you want somebody with 5 to 7? Well, we need somebody with 5 to 7. You're not going to find them at the school because I'm not leaving my job. Like the only guy here able to do that is me, and I'm not leaving. So, But yeah, it's so I mean, like just putting that in perspective, like that's one of the things I want to do is put that 750-hour program in there. Now that we have more employers asking for pipe welders. So I think that's going to help out a lot. A lot of students want to do pipe. I'll show them a little bit because I've picked up some from my buddy Brian Legalio, Ryan Eubanks. I've got a good concept of it, so I'll just give them like the basics. Like we can run some 60-10 downhill and uphill and fill and cap with a 70-18. That's pretty much, what we'll do for the students that get ahead far enough. So like the last 6 weeks or so of our level 2 program, we pretty much have all the curriculum out of the way. That last 6 weeks that's the time where they can go in and they can dial in and get focused in on like, okay, little Tommy, you want to go structural steel? Okay, you need to focus on, take the engine drives outside, hook up the LN25 to the Ranger, fire it up and go run some 1-inch test plates with 7018 or the NR233. Okay, Susie, you're wanting to go over here to this company. They do some like really thin gauge TIG, go grab some of that 035 or 35 thousandths material from the back, set up a couple of lap joints, and then we'll go through that. So everybody can kind of hone in, they identify where they want to go and then they skill up to get into that position.
Yeah. And that's one of the things about coming to school. People know about welding, but they don't know all the different aspects and all the avenues they can go through. And like you, we try to show them as many different avenues. We talk about maritime shipbuilding. We talk about fabrication. Unfortunately, we don't have a lot of fabrication in our area. We talk about, pipe welding. We talk about the pipeline, cross-country pipeline stuff. And we talk about inspection, because I tell my students, one day you're going to be older. You're going to be 40, 45, and you're not going to be able to get up as good as you can now. Your back's going to be hurting, knees going to be hurting. So what's your career going to be? What's your career goals? And talk about inspection and being into supervision, being a foreman, general foreman, that type of stuff. So yeah, we try to show our students as much the different areas and the avenues in welding so they can make that choice of, well, I really don't want to travel. So I want a good paying job. I said, well, there's several shipyards in the area. There's, some over in Mobile and in Mississippi that have, long-term employment benefits and you're home every night and it's a good job. You can go that route. Or if you do want to travel the country, still young, don't have a family, you want to travel the country, get in construction. I've worked with some iron working companies, structural steel companies, work a lot with pipe companies. Because again, I was a pipe welder, so that's my focus. And like I said, not a lot of fabrication. We do have some fabrication. We put some students to some fabrication in the area and they've enjoyed that. The hourly pay wasn't as large as on the job, construction job. But again, they want to be home every night because they had the family. And that's where, and I'm like, you've run into this. Every student's got their own personal situation. So you try to let them make that choice and guide them to the career that fits their situation so that they're the happiest they can be. Mm-hmm. If you got somebody with a family, young family, and they go on the road construction, you're like, dude, that's going to be a hard life because you're going to be missing a lot. You'll miss the birthdays and the anniversaries and the dance recitals and Little League ball games. Oh, I can handle it. It's not as easy as you think it is.
Yeah.
So
I was talking to one of the guys on the podcast, and like he had to do a weld test on Easter Sunday. Like he's out there doing the weld test Easter Sunday. Yeah. Family's back home. Yeah. And it's like, damn, I mean, it really puts things into perspective that these jobs aren't shutting down because you got holidays, birthdays, dance recitals, Little League games. That's when that's why they're paying you the money that they're paying you. That's why you're getting that nice hefty per diem check and, all this ridiculous amount of overtime and stuff like that because the job has to get done come hell or high water. We got to get, and if you're not going to be here, well, guess what? Well, somebody's going to fill your spot. Your job's not going to be there when you get back.
Yeah. My dad had a saying, there's a barefoot boy at the gate wanting your job. So if you don't want your job, that's fine. We'll find somebody that does. Because like you said, the job has to get done. And it's a difficult career. It's a rewarding career. And I enjoyed being on the road. But again, I had a young family. I got married. Me and my wife had 2 kids. And we had a phone call one day. She's like, I'm tired of being a single mom. I need you home to help support me and be part of this family. So I do not have an ex-wife, so I came home and kept the family together.
Rolled the tools back up.
And it was well worth it. But yeah, the traveling aspect is definitely difficult, but I love building things and to look and to see that power plant or that paper mill or know that is running because of what I could do and what the hours I put in and the skill I have. That I just love that. And the one thing I do, everybody talks about, a lot of people, welders, it's not a really, they kind of talk down. Welders help keep a paper mill up and running. And the last time I checked, toilet paper is made from trees and it has to go through the paper mill. So if you don't have welders, you don't have a paper mill, you run out of toilet paper. So how important did we just become?
Yeah. Well, I mean, look at the middle of the pandemic when everybody was running for toilet paper. I mean, that's how important was it then? I mean, think about it. Welders make the world go round. Like, and I always used to get into battles with or not battles, but like verbal debates with other trades because they thought they were so badass. They're like, oh yeah, we're so much cooler. Like, because we're electricians and everything. It's like the power wouldn't be on. It's like, if the iron workers didn't come in here and put the structural steel building up, you guys wouldn't have anything to, run your conduit to. Uh-huh. So if anybody's more important, it's like the dirt work guys, number one, because otherwise we wouldn't have been able to lay the foundation. Then the concrete guys. So, I mean, it's a joint effort. It's a group effort, but I still think the welders are the best of all trades.
I do too. And the electricians are always talking about, without us wouldn't be any power. It's like, really? I got an engine driven.
Yeah, I got an engine drive right in the back of the truck.
I just start that up and I don't need you. But yeah, it takes everybody to do it. And again, I kind of go back to the fact that a skilled trade has been essential since, the industrial age and will always be essential workers and will always be needed. And whether, again, welding, electricians, pipe fitters, plumbers, carpenters, concrete guys, operators of equipment. And this just without our type people working, our society, our way of life would stop.
Yeah.
So
how do you go about placing your students with employment? Because I would imagine that's part of, what you do as a welding educator is you place your students with employers. But I mean, like you said, you're in a service-based area. So I mean, it's got to be kind of difficult to get them placed when you don't have the industry around you. Yeah,
we have had a 95, 98% job placement rate. I was fortunate enough that I brought in some relationships with the companies I'd worked for, and we have weld test days. So that at the end of the fall semester and the spring semester, so every May and every December, the graduating students we have them do weld tests. We call the companies will send in their inspectors, and our students will do a weld test in our shop, and the inspectors for the companies will look at it, grade it. If they pass, the student will they'll put the student's name on their hire sheet, and we have our students do a resume. So our students do a resume, we hand the resume to all the inspectors, and that way they have all the contact information, and they do a weld test, and we have weld test days. And this last time in May, we did it, and we had 9 different companies come in over about a 3-week period. So that's where we've been real fortunate to have those relationships with those companies come in, and we've had people come in from companies come in from Arkansas and Georgia, Tennessee, and it's been very fortunate that we got those relationships where the students have the opportunities. We never guarantee a job.
Yeah.
I guarantee my students I will do everything I can to give them the opportunity for a job. But it's been that's the way we do it. We set those up several months in advance. The companies come in. We get a few calls from companies. Usually shipyards around here will call. There's one one shipyard got a big contract with the Coast Guard. They're needing welders, so we send some folks out there again doing the flux core on the suitcases like you were talking about. Because of our area, we wind up having to recruit companies to come in, and that's the way we do it. How's your replacement rate look? You do pretty good?
Yeah. So, most of the things, I do something very similar, but I reach out to local industry. So I go out and I talk to, apparently, unbeknownst to me, Florida is number 2 right now when it comes to manufacturing, which is
really,
it's kind of awesome because just I want to say yesterday, I received three phone calls, and between the 3 phone calls, they need 9 students.
Dang, man, that's awesome.
And I just had a graduating class. So my last class graduated June 10th. We had a couple of them placed prior to graduation. I've got some of them that are waiting on responses from interviews because they identified with one company. They practiced for that company. They went down there and did the weld test. So he's waiting on information coming back from the employer. But pretty much everybody that wants a job coming out of the program gets a job. And that's the thing. Like you said, I can't guarantee you a job because I can't guarantee you're going to get off your ass and go to the interview.
Yeah.
At the end of the day, you got to be real with me. But if you want a job, if you go through my program, you identify with an employer and I don't get a kickback from any employers to hire students or anything like that. There's nothing like that. So I tell the students, here's the employers that I work with. I've built these relationships. I've been to their shop. I've seen their procedures. I know what they're looking for. And then, during that 20 to 40 weeks that I'm interacting with those students, I can say, hey, you'd be a really good fit for company A. You'd be a really good fit for company B. And I'll reach out to those companies and say, hey, look, I got somebody, and I just placed another kid right before he even graduated. I called him up. I was like, hey, are you guys hiring? He's like, yeah, man, I need one good guy. And I was like, I got the perfect guy for you because he wants to do exactly what, the type of work that you guys are doing. Let me send him over. Mm-hmm. Went over there, crushed the weld test, crushed the interview, passed the whiz quiz, and he got hired, prior to his graduation date and then started the following Monday.
Yep.
But that's what I do is I just reach out to local industry, find out. We've had big companies come in, and obviously I'm not saying the names of these companies because I'm not giving up what I got going on in the area.
Yeah.
But they'll actually come in and they'll administer the weld test there at my shop. Mm-hmm. Or they'll give me their welding procedures. I'll administer the test. We'll send it off to a third-party testing company, and then they'll accept that as passing their entry-level exam to get in.
Yeah.
But to do that, I had to build a relationship with them. I had to build a rapport. And the first time we ever did it, we welded up one test plate. I sent it off to a third-party testing lab. I then took the film and the plate back over to the company that was, I was working with, because we had to sign an NDE with them, so I can't really expose any of their trade secrets. But gave them the plate, and it's Inconel, or it was Inconel to stainless, stainless to stainless, and Inconel to Inconel. So they had to run 3 tests, get 3 films, take that into the company, give the company the actual plates that were welded by the student, plus the 3 films. They ran it through their radiograph. They got the same exact results as that I did through the third party. So they're like, okay, if you test them at your facility, you send it to that same third party, we'll buy off on it and hire them. And that worked well until, they started promoting people up the chain. Now I got to build a new relationship with the new guy. That's always a pain in the ass. But and I get a lot of employers that reach out because we're building a name because we have a brand. And that's what I tell the students. When you leave, you're a direct representative of this school and me. So don't go out there and embarrass either one of us.
Yep.
You know,
and that's one thing I tell my students is you go out there and you're exact same thing. You're representative of this program of me, but you're also, if you screw up, you ruin it for the students behind you.
Yes.
Because if you do a great job and you work hard and you can weld and you do good, then that employer say, you know what, I want more people like that. Let me call that school again and get more students hired. If you screw up and it only takes one time to ruin it, then they like, you know what, I don't want anything to do with that school. Mm-hmm. So you ruin it for everybody behind you. And I tell my current students, you have opportunities because the people in front of you did good. So it's not just you. You got to do your part, absolutely. But because of what me and the staff I got and the students before you have done a good job, they built that rapport, they built that relationship, they built that brand. The companies keep coming back. Mm-hmm. So once you're done and you graduate, you're still a representative. So you can either make us look good and help us, or you can ruin it. So yeah, I'm like you. Don't be a dummy and do stupid stuff, and just do what you're supposed to do. And I agree with you. You have to look at each student's kind of personality and go, okay, yeah, you really don't need to go to this one. You need to go over here, and you'd be a great fit over here. But they go, oh, I want to do this. I want to do this. Buddy, no, let's kind of, you got to gently steer them, because tell them no, but you kind of just nudge them back over this way. Yeah. As far as students, what's your opinion on this? Do you find that the female students, the girl students, are better than boys?
95% of the time, only because the majority of the time, if I have one female in the class, they're usually there to prove a point. Mm-hmm. I don't want to say prove a point, but they're there to basically prove to themselves and everybody else that I can do this just as good as you can. And I'll be damned if they do, or damned if they don't. I mean, they kick ass when they come in the program. And I've said it 100 times before on the podcast. The hand-eye coordination, the attention to detail, the ability to follow instructions.
Is amazing.
Whereas like a man or a guy, they go in there, they're like, I'm going to muscle my way through this and I'm going to figure it out. And I don't need to listen to that guy with the red beard over there and, the instructor jacket, because I watched some YouTube videos last night. I got this. And I've seen it time and time again. And be like, all right, when you're done screwing it up and grinding out all those passes, come get me and I'll show you again how to actually do it. But the females, they just seem to do awesome, especially with TIG welding. Yep.
Yeah, the hand-eye coordination for TIG, they're amazing. My most successful student from the school I'm at now has been the female in my very first class. She knocked it out of the park. This past semester, this past spring, was the first semester I hadn't had a female in my class in about 3 or 4 years. And I miss a female in the student. It changes the atmosphere for the better. And I think that really helps having females in the program, the females that are serious about learning. Yeah. And they aren't going to be a problem any student could be a problem. But you get a female, like I said, that's serious and dedicated. It
changes the whole dynamic. Yeah.
And they challenge the other students, challenge the guys, and like, this girl's doing better than me. I better step up. So I think they do better as students and better in welding as a craft.
Yeah, and that was the first class I ever taught back in 2014. That was I had a female in the class, Lori Arnold, and I'll never forget it because her husband is the union pipe welder that I was telling you about earlier. Mm-hmm. But she wanted to learn how to weld, so he said, okay, if you want to learn how to weld, you're going to go to school and you're going to learn how to do it right. And the funny thing is, he's an instructor for the pipe fitters union. But she came into my class and it was perfect because she would just go through and learn a process and then be ready to test out on it. And so by the time she finished up the program, she had 16 welding qualifications. This is all done third party. This wasn't, at the time, I was not an inspector. I'd look at it and be like, all right, we'll send it off and they'll do a visual and they do an x-ray on it. And she got 16 weld quals. But the cool thing is all the other guys in the program, they were just steady trying to catch up the entire time. So it's like, oh man, Lori's got another one done. Okay, I really need to focus in on this. And it kept everybody on edge. It kept them on their toes because, they didn't want to get beat by a girl. Not that there's anything wrong with it. I mean, if she's got the skills to do it, have at it. But it kept it put them into a competitive nature. And so they started taking it very serious. Yeah. I thought that was awesome.
Yeah, and like I said, it changed the atmosphere of the shop. It does for me that everybody's, like you said, a little more focused because, hey, everybody, when one student steps up and they're excelling, everybody wants to I don't want them to get ahead of me. And not that I foster a competition, but I don't hinder it either. I let it kind of the natural progression, so there is a little bit, like I said, that competitive edge, competitive nature, and that makes the students try harder and harder, and just drives them, and they get, I think, do better that way.
Mm-hmm. No, 100%. It's really cool having those students, that like we started doing interviews for students coming into the program, because like I tell my administration, it's like, I get it. You guys want like 100% completion rate and you want 100% placement rate, but at the end of the day, we got to be real with ourselves. You can't make chicken soup from chicken shit. So we got to start off with good stock. So I implemented an interview process. So I interview all the students that are coming through the program to find out if they're going to be a good fit. And based on their score, they either get admitted into the program or they get put on a wait list. And then we can come back and readdress some of the issues. But I spoke to a young man today, and like he's like, oh yeah, like he's throwing out terms like polarity and gas metal arc welding and shielded metal arc welding. And I was like, how long you been welding? He's like, I haven't welded yet, but I've been reading a ton and doing a lot of research and watching a lot of videos on it. And it's like, okay, cool. This is the type of person that's going to come in and kick ass and take names. I want a whole class full of those people. They know exactly what they want to get out of the program. They know exactly what they're getting into, and they have a goal for once they complete it.
Yep.
I don't want to train, and don't get me the wrong way. I love teaching anybody how to weld, but
absolutely.
If you want to come into the program, like you said, we're changing lives here. We're making opportunities, creating opportunities, and putting you in a better spot than when you came in. So I really don't want you to come to the program if you want to learn welding as a hobby.
Yep.
That's not what this program's designed for. It's not how it's set up. It's not how it's ran. We can set up like weekend workshops that we used to do. You can come in and learn how to do some MIG welding and some oxy-fuel cutting. But, if you just want to come in and learn this to do an art project, or, you always thought it'd be something cool that you want to get into before you retire, probably not the program for you. It's a little bit more fast-paced.
Yep.
And it's a little bit more industry-driven.
Yeah. And the same way we have an orientation. We do an orientation and tour, which we ask the students to come down to the shop. And I sit them down in the office, and the first question I ask them, why do you want to take this welding class? What is your goal for welding? And I'm like, I want to build motorcycle frames, and like they do on TV. Buddy, I appreciate you coming in, but you might want to look at another one. Because I'm like, hobby thing, do artwork, not what it is. And we have weekend, we call them hobby welding classes we do on the weekends from time to time, and that's what that's for. This is fast paced. It's 35 hours a week. It's 18 months of your life. You got to be dedicated and committed to it. And so if you just want to do it to be, maybe I thought it'd be cool, not the program for you. So we do the orientation as well. And our school allows us to implement a drug test.
I was going to ask you about that
program. Yeah, the students have to pass a 10-panel urinalysis that they pay for to get admitted into the program. And that is really weeds out some folks that may not be as dedicated as they thought they were.
Right.
So I guess that's the best way to say it. And it really, and like you said, how can you build a program on a foundation that's cracked? And having students that aren't committed, aren't employable because of whatever issue they have, you can't build a solid program that will be sustainable. And I 100% agree with you. You got to make sure the students, the program fits the student situation. And if they do want to do some artwork, that's fine. Nothing wrong with that. But this isn't where you'll fit in. This program will not meet your goals. So we need to help you find another program that can fit your goals. And it makes it, if the program doesn't fit the student's goals, they're not going to enjoy the program or reach their goal because it doesn't fit. So having that interview, that orientation, I think is a big part of making sure the program fits the student's needs. So
I do like the fact that you guys do a drug test prior to bringing them onto the program. That's got to say something to your employers when they come down and they call you up. They already know that, okay, this individual's already, or the students in the program, they've already been drug screened before. So, we've got a pretty good chance of getting one that can pass a whiz quiz.
And that was something they said when we first started going. We had the advisory committee, had a few employers, and they like, we need to make sure that your students are employable. And I talked to the administration. I said, we need to have the drug test because my advisory committee of employers said that our students need to be employable beyond just the welding skills,
the skill set.
And it's helped out a great deal. And it's tough. And there's sometimes you'll be talking to somebody and you'll tell the student about I really don't. And the other thing is, I actually had a student tell me that was the final straw that got him away from the drugs because he did want to be in welding. And when he realized his extracurricular activities were stopping him from reaching his goal of being a welder, he said, I got to clean my life up. I've got to make a change. And that barrier, he wanted that barrier gone, and he changed. He didn't make it that year, but he came back the next semester, passed drug test, and he's had a great career as a welder. And that drug test helped him realize, hey, it's time to get serious and time to clean my life up. So that was one good positive thing about it, other than, of course, helping him be employable. So it was I think a big step that I'm glad it happened. I was a little surprised. A lot of times schools are real scared to do that type stuff. Yeah. But my administration, where I'm at now, they really supported us when we got this set up, and we've had it in place ever since I started it in 2013. So it's been a big help for us.
All right, we're going to go ahead and take a quick commercial break. This segment of the ARC Junkies podcast is brought to you by Strong Hand Tools, makers of the coolest fabrication tools in the industry. They have everything you need to increase productivity and improve accuracy, whether it's fabrication tables, clamps, magnets, or their shop safety products. They've got it all. Check them out today at stronghandtools.com/ArcJunkies and see how they can help you on your next project. We're also brought to you by AHP Welders. They have some great machines for under $1,000. They just released the new Alpha TIG 203 XI, and it comes with just about everything you need to get into TIG welding right out of the box. And right now, you can get an upgraded Nova foot pedal and TIG torch when you use ARC Junkies in the comment section at checkout. Stop by ahpwelds.com today and take advantage of this great deal. Now let's get back into the show. Nice. That's one of the things I tell one of my students, when they get into the program. It's like, that's a very simple test to pass if you start studying now, because you're going to be in this program for 20 to 40 weeks, depending on which program you're taking. If you're doing level 1 and level 2, or just level 1 and going to find a job. But we have companies in our area that do a hair follicle test.
Ooh.
So it's not like you can borrow your buddy's hair and bring it to the testing facility with you. They literally shave off, I think it's like 60 to 80 strands of hair. They get a good patch out of you, jackass style with the clippers.
Yeah.
And they test your hair, and that can go back 6 to 8 months depending on what you've got in your system. So if you start studying today, by the time you graduate, you should be able to take that test no problem. Yep. But it's up to you. They pay really well. They work a lot of overtime. They've got great benefits. But if you can't meet that basic minimum requirement, I don't care how good of a welder you are, you're not going to get to the interview process.
Yep. And that's one of the things to me is, I think as a school, and I tried to do with our program, is set up so our entry into the program is also basically the entry into a job. So what you said, the employment requirements for any company, that's kind of what we did entry in our program, and make sure our students can meet that when they leave. You mentioned it before. Can they read a tape measure? And that was one of the things that really surprised me is the young people coming into school, they have never used a tape measure and just didn't understand that. Couldn't add and subtract fractions, so we actually have what we call Worksheet Wednesday. Every Wednesday after roll call, we'll do a worksheet. 1 week it's on add and subtracting fractions. The next week it's on reading a tape measure, and the next week it's blueprint reading. So through the whole program, every Wednesday, they're looking at this stuff over and over so that when they get out, they can read a tape measure. And I had a student come back this past week, young lady. She got a family. She's getting a job at a fab shop, and went in for the interview, the weld test. And one of the first questions the guy asked her says, "Can you read a tape measure?" She's like, "Yeah." And so he gave her a part, said, "All right, measure this out for me and write down the measurements on, make sure you can get within a 16th of an inch." And she thought to herself, man, I'm glad we did those worksheets, because without that, I wouldn't have known how to do this.
Yeah.
So that's one thing, is making sure the students, when they leave, I think part of the entry should be, can they meet the minimum employment requirements of companies? And then when they leave, they definitely need to be able to meet those requirements of, reading tape measure, passing the drug test, have those soft skills of attendance, showing up every day kind of deal. And I don't think that's emphasized in the high schools as much as it should be, is you got to be there every day. Just because you feel got the sniffles, walk it off, buddy. Let's go.
Yeah. So. That was the tape measure was one of my pitfalls when I first got into teaching, because I took everybody's word for it. So we're in the classroom. I was like, all right, how many of y'all can read a tape measure? I had 14 students. They got 14 hands. I was like, cool, we don't need to cover that. On to the next one. And then we got into the shop, and I'm like, hey, I need you to take go back there and grab that 3/8 thick plate, 6 inches wide, and I want you guys to cut them down into 6 inches long. Just take it over there to the iron worker. I showed them how to use the iron worker, and we're going to shear them all up. And go ahead, set up the dead man, and all this other stuff. And I'm getting parts that are like all over the place. I'm like, whoa, what are you guys doing? Well, we're measuring these parts out. We're cutting them just like you told us to. And I was like, well, none of these plates are the same length. Like, what are you doing? And so it was at that moment, that I knew I screwed up, and I was like, all right, everybody back to the classroom. So now what I do is day one, I cover the syllabus. We cover like the course layout. So we have a course calendar that kind of tells them what they're going to be doing day by day, week by week. And we stick to it for the most part. But once all that's done, we do the introductions. We talk about welding safety, and then we get right into a tape measure. How many of y'all know how to read a tape measure? Everybody raise their hands. All right, cool. Take this test. I pass the test out. It's usually right before lunch. Everybody takes the test. They go out to lunch. They come back. I've got everything graded. Okay, so it looks like, 3 of y'all out of the 13 told the truth, so 10 of y'all are lying to me because I don't know what these measurements on here are, but this is not right. So, okay. And then I pass out a worksheet. My buddy Ryan Eubank showed me. It's a 1-inch tape, or it's just a 1-inch section out of a tape measure, but it's on an 8.5 by 11 sheet. And we go through each little tick mark, and we get them down to the 16th, and then we just start building on that every time. And that's one of the things that, like, you need to have work boots, jeans, cotton shirt, 4-inch sleeves, and a tape measure every day when you show up.
Yep.
The other tools, we got plenty in the shop. We'll figure it out, but you at least need a tape measure. Got to have a tape measure. I don't provide that. I've got spare hoods, spare jackets. I don't have spare tape measures. Bring your tape measure in.
Yeah, and it was so funny to me is I wound up at the end of the semester. I always wanted like 2 extra tape measures. Somebody laid them down and didn't realize it, and would go do a project and go grab your tape measure. Well, I think I laid it down somewhere and somebody grabbed it. Oh, you mean this one right here? Yeah, where'd you find it? Well, you left it on the ironworker on your last project, and
6 weeks ago.
Keep up with your tools.
Yeah.
So, and we in our toolkit, but the first toolkit we have tape measure. So the first semester they're in there, that's when we're hitting on the tape measure. Every time we do something, cutting metal, whatever, they got to get out and mark it, get the soapstone, and it's soapstone, not chalk.
Yep.
I don't teach third graders. Oh, I need that welder's chalk. It ain't welder's chalk. It's soapstone.
Yeah.
So yeah, we do the same thing because it just, again, I was just surprised at how many people just never even done it. And I guess because they don't have shop classes or anything in high school anymore,
that's what surprised me. And it was like, and I tell students now, like I always start the conversation off with, look, I'm not insulting your intelligence, but because of previous experiences, I'm going to go over and walk you through the safety aspects of this hand tool or this power tool or whatever the case may be. Because like I've told this story on the podcast 100 times. I gave a drill bit, and a pop rivet kit to a guy, and I said, hey man, I need you to go install this lock hasp on that new cabinet over there. Just drill out the holes and put the pop rivets in. I said, I'll be over there and check on you in like 20 minutes. He's like, all right, no problem. Now this man said, all right, no problem, with like 100% certainty and confidence. And I walk over there and he can't figure out how to get the drill bit into the drill to make it hold, let alone which end of the drill bit to use. So I was like, man. Oh. And this is a kid, he's like 23, 24. So I was like, okay, we need to have a conversation here. This is my fault. I thought you were a little bit more proficient with power tools than you are, obviously. So here's step one. So I quit taking things for granted because, like, when I grew up, like, we used to build things all the time. And kids today, like, they're not really building anything unless it's on Minecraft or Roblox or, whatever the hell they're playing. So, I mean, there's no... And that's one of the questions on, my questionnaire when they're coming through the program. What tools have you used related to this trade? And they're like, well, I've never welded. And I'm like, I'm talking like basics. Have you ever used a framing square, a carpenter square, a set of clamps, vice grips, anything like that? Just to find out where you are mechanically. And most of the students that are coming in, most of the people that are applying, they've never used any hand tools.
No.
Every once in a while,
you start talking about squares.
Yeah.
And you tell them, oh yeah, I need the carpenter square, or I need the speed square. You mean the triangle thing? Yeah, the triangle thing.
Yep.
And I'm like you. I tell everybody, I said, I assume everybody here knows nothing. So I'm gonna start at the very basic level. And if you know this stuff, just bear with me, because sooner or later we're gonna catch up to you. But I gotta assume everybody here knows nothing, and we're starting like fresh babes. Everybody's brand new, never seen the grinder or the drill or whatever it is. And that's the way we run it. That everybody knows nothing, and we build up from there. Yeah. Because like you said, you assume they do, and you know what happens when you assume.
Yep. That's the thing, man. I started teaching everything just like I was taught in the Marines, and like I had to teach in the Marines. Break it down Barney style. Like very, very simple. Use the KISS method. Keep it short and sweet, and just try to make it. I try to make everything relatable. Because if I can relate it to something that they already understand, they catch on a lot quicker.
Yeah. What curriculum do y'all use?
So I use a mix of, because I know you use NCCER, and I was going to ask you about that, but I use a mix of, that's kind of the base of my program is NCCER. But I don't buy the textbooks because I found that my students don't read them. I also use a little bit of AWS. I use a lot of their code book stuff, so like the D11, D15, we get into those different aspects of it. And then a little bit of, so Lincoln Electric, if you're part of, or if you're an educator and you're down, if you have access to the portal, you can actually get technical manuals through Lincoln Electric. So there's gas tungsten arc welding, gas metal arc welding, stainless metals, the C1.10 book, which is a consumables guide. So I use that, and those are like, these are all free textbooks. Because what I did when I first started teaching, I made everybody buy a textbook. And then I'd make everybody read the chapter, answer the questions in the back of the book. And I found out that only like 30% of my students were actually doing this, because once they leave at the end of the day, they've got lives, they got kids, they got wives, they got jobs, they got all this other stuff. So they're not reading the material. So I was like, okay, if you guys aren't going to read it, you still need to be exposed to it. So I took a mix of all this information, everything I need them to know. I put it into a PowerPoint presentation, and that's what I teach usually on Mondays. And then we'll test usually on Thursdays. I kind of want to adopt your style of doing it on Tuesdays and then testing, or you teach on Thursdays and then test the following Tuesday. So I want to adopt that style, because it would at least give them a couple more days for that information to sink in, outside of a work week.
Yeah, and I did Mondays at one point in time, but I found, like you said, people got lives, they got the weekend, and they'll remember it Sunday night at 10 o'clock when they go to bed. Oh crap! And then they probably won't do the homework. So that's why I like the Thursdays. We do the lecture in the morning time. Then we go into the shop, and that gives them Friday, Saturday, Sunday, Monday, and then we do our test on Tuesday. So it gives them a little extra day. So when something does come up in their life on that weekend, they still got time to do it. And I'm like you, I did find that the students weren't really getting the textbook like I wanted to, but then the NCCR books, they adopted the last version questions at the end of each section. So within a chapter, they got like 2 or 3 sections, and then each section will have like 4 questions. So I have my students do those section questions before the lecture.
Okay. And
we go over it and look at it. That way I know they've at least been through the chapter enough to answer those questions. Then we'll do the PowerPoint, or the same thing, a PowerPoint presentation, got some videos put in there, kind of break it up so it's not just me talking the whole time. And then on the day of the test, they have to do the review questions there at the end of the chapter. So they actually have 2 sets of questions, one before we do the lecture and then one after the lecture. And I found when we implemented the ones before the lecture, those section review questions, it helped out a lot. Their test grades really climbed, because when going into the lecture, they had some idea of what it was going to be about. They'd been over the information, and it took me finding those section questions to come up with how to get them in the chapter before the lecture. And like I said, there's only like 4 questions per section, so it's not like it's an overload of homework. It takes them, if they're serious about it, 15, maybe 20 minutes to get that done before the lecture, and they have some idea of what it's about. They've actually got some questions formulated about the material, so it kind of gets them a little more engaged in that lecture. So that's what I found worked for me in doing that, because I had the same struggle. Students would come in glassy-eyed. I don't even know what we're going over today, and then you're trying to relate it, and they don't even know. They don't have any questions, and so yeah, it was a struggle for a while.
I started shifting a lot of the stuff so I'll teach it in class, and instead of doing like a written exam, I mean, we still have written exams, but it doesn't carry the same amount of weight that our practical exams do. So when we talk about, we'll talk about equipment setup, equipment troubleshooting and setup. They'll have an in-class exam. Okay, great. You guys, you got some information on there. You get a basic general idea of what you're doing. Let's go out in the shop and see if you can do it. So I'll take a machine, I'll strip it completely down and say, okay, you're going to set this up for gas metal arc welding 035 short circuit. Go. And like drive rolls, everything is stripped off. And they got to set it up from beginning to there. And I'll have more stuff laid out than what they actually need. But there's a rubric. How long did it take you to do it? Did you make any mistakes? Did you need help or assistance along the way? Same thing when we get into oxy fuel cutting. You have to take the tanks. You have to set everything up from, everything's capped and rolled up, and you got to take it from absolutely nothing, set it up completely, draw out everything that you're going to cut, make your cuts, do all your safety checks, break everything back down, and set it up for the next student. And so I'll do rubrics that way. Same thing with plasma cutting. Everything's taken off. And I tell them, when we cover plasma cutting, like there's a cheat sheet that's a sticker on top of the machine. So you really have no reason why you're going to screw this up. And some of them surprise me. They'll screw it up, and it's like, look at the sticker. It shows you exactly how the parts have to go in there. But then they have to set it up correctly. They have to dial in the appropriate amperage, and then cut out, whatever parts that they're working on. And so they'll get graded on that. So I prefer to do more of the hands-on testing to make sure that, okay, this is what you're actually going to be doing. It's good to understand the fundamentals and the basics, because for a long while I was teaching like way too up high for a lot of people.
Yeah.
And I was like, okay, I got to bring this. I've got a lot more experience, a lot more relatable skills. I got to bring this down a couple more notches because they haven't been exposed to as much of this as I have. So I started doing more hands-on practical stuff. I do like the stuff that you had in your book when you do your weld testing. Single fillet on one side and a multi-pass on the other. So I incorporated that, and I'm just going to tell you right up front is I completely stole your rubric out of the back of the book that you have. I think you pulled that from NCCER. But
take it, man. You're more than welcome to use it. Anything you find in there useful, take it, man.
I've been using the hell out of it, and I got my new instructor using it too. So we'll draw the plate out. It's just a 12-inch long T-joint, and then I'll stamp. So whatever side is stamped, I'll put an S on one side, and then on the back side of the T-joint, I'll put an M. So that way you can't put two roots down and be like, okay, this is the better of the two. I'm going to, this one looks like crap. I'm going to cover this one up with the multi-pass. Maybe I'll get it on the second and third pass. No. So this side says single, that side says multi-pass. So you only get one shot to put in that perfect root. So, they've got to figure out exactly how to do that. And I make sure they got, it's completely filled for the cross section. There's no undercut, porosity, weld spatter, all that stuff. I go through the same thing, same rubric you set up. And I give them 5 points off for, each discrepancy, regardless of it. If it occurs multiple times on both sides, you only get docked for it one time.
Yeah, and I actually come up with that. That hit me because on a weld test, if you get a strike mark on a weld test for a job, it don't matter how many you have. You got one, that's one too many. Yeah. So that's kind of where I came up with that idea of, and plus, if you keep hitting somebody for the same thing, get them multiple points, and you're going to break their spirit. And that's not what our grading is, to show them where they need to make corrections and helps us as teachers see where they're deficient, so we know how to train them and work with them on those certain areas. Because as you know, every student has different areas they need help with. So I didn't want to just keep beating somebody over the head with strike marks. Oh, I'm going to take 20 points off because you got 20 strike marks. And that to me seemed a little excessive. So you got a strike mark, 1 or 15 of them, it's just so many points. But I found it worked pretty good, and it works really good. And it really makes the students concentrate. Okay, I got to make sure this weld is good, because this is the side that's going to be graded, so I can't cover it up. I've got to make sure it's good all the way through. And it gives them, again, what part of that was that test anxiety, just a little bit, so they can learn how to cope with that and still make good welds that's going to be passable and acceptable. Because you're in a weld test for a job, you got to be able to pull it out and be able to do it, but they don't care if you're nervous. You got to make the good weld.
Yeah. I do like the fact that you time your test. So like with your weld qualifications and stuff like that, because I tell them, hey, once you fire up on it, I got to inspect the root, or I got to inspect the fit up. You guys are going to weld it out. I'll inspect the root, and then the filling cap is up to you. Don't take it down. Don't touch it. Don't move it. Once it's done, come get me. I'll do a visual right there. And then, we'll go ahead and take it down. I'll put the actual tools on it, and then we'll see if it passes, if it meets the D11 specs or whatever code we're welding to, for that specific test. But I do like the fact that you put in a time limit, because that makes it a little bit more real. That adds a little bit more. So I think that's something that I want to incorporate. We've got a class starting July 5th. I want to incorporate that in the next class to get rid of some of that fear and anxiety, and, start giving them different tests other than, like the D11, D15, D12, like all these, ASME, all this stuff.
Yeah.
Just here's a widget, build a widget, and you've got 45 minutes, go. Yeah. Like, when you're going in for an employment, they give you a weld test. You don't know what it's going to be. And so many schools I'm training to certify because we get CAPE funding.
Yep.
I'm lucky. I don't get CAPE funding. So it works out perfect for us. It's a long story. So we don't get CAPE funding. So I don't train students to test because I've never had that incentive. I train them to get employed. Now, a lot of them leave with weld qualifications. I encourage them to get it. And I tell them that, hey, once you test here, it doesn't mean you can go get a job anywhere. You're still going to have to test for every employer that you want to go work for. And if they don't, those are the ones that probably aren't going to pay you well. If they take your school certs, you're probably not, at the end of the day, they're probably not going to pay you as well. They're probably not going to have the same benefits because they're relying on somebody else to do the work for them. They're obviously not familiar with the work, so they're not bidding the work correctly either. They're not bidding on high-end work. So those are the companies you want to go to work for, is the ones that are actually going to test you. But a lot of employers, they don't train to D11 specs, because that's not what they're doing. So they train on fabrication skills. So here's 8 pieces of metal, go build me a box. You got weld up all these outside corner joints. Make sure to wrap your corners. There's the machine, go. And so that's some of the stuff that I want to incorporate more of into the program. So once they get done and they go get a job somewhere, it doesn't matter if it's a D11 plate test or a fabrication project. I think adding that time on there is going to alleviate some of that fear and anxiety.
Yeah, because like I said, they'll get used to that. And my time limits would double what I did. So I would do a weld, and then I kind of time myself. I said, okay, I'll give them twice as long as what it takes me. I know there are students going to take a little bit, but if it takes you more than twice as long as it takes me, then there's an issue somewhere, and either I haven't trained you right or you don't understand what needs to be done, and you're taking too long. And I've had students that are better grinders than welders.
Yeah.
And they'll do a weld bead, grind half of it off or grind the whole thing out and then do it again. I'm like, no, you got to learn to, and that's part of that test. They want to make it perfect. I understand that, but you got to understand what's allowed and what you need to be able to do, because that time limit is going to get you as well. So you can't spend all day grinding out a weld if it's not perfect. So you have the perfect weld because you want to make sure everything, because it's a test. No, you got to make a good weld, a solid weld that will meet what you need to do and keep moving on, because that clock's ticking. It don't stop. And I didn't think it was going to be that big a deal, but it really makes them feel that pressure. But like I said, not so much that they freeze up, but I do realize I can find which students have that anxiety for taking a test. So I go, okay, let's work on that. Let's do some other things and try to give them mechanisms to work through that, so that when they do go to the employers and the employer throws something at them they're not used to, they don't just freak out. They go, okay, I've done this before in school. Let's handle it and let's move on. So
that's one of the things I like to do is I'll train them to D15 specs. So you can't use. There's no grinders, there's no air chisels, there's none of it's a weld test, not a grind test. So if you take a crap on the root, guess what? You failed. You owe me 8 hours of practice before you can test again. So that's kind of the way, until we get if we get the last couple of days, if they were really close, I'm like, all right, go ahead and run another test plate. Otherwise, man, they're just cycling through plates, and it was like, I can't be having this. And that stuff adds up quick, especially now that they raised all the price on materials.
You ain't lying.
I had to do a price comparison between pre-COVID and post-COVID prices, and I sent it up to my administration. They're like, "Oh, you must not have misunderstood. We don't want to know what it costs to run a cohort. We want to know the price difference between the 2019 and the 2021 school year." And so I sent back. I was like, "That's the price difference. That's not the actual cost of the program. That's how much the increase of sheet metal, plate, contact tips, all my consumables. That's the difference in price." And they're like, "Oh, yeah, okay." Surprise. Yeah. Welding just got more expensive.
That's the thing I was going to say. Well, a welding program is expensive. I mean, just like I said, the material, the consumables, and there's so many consumables. I mean, the rods, the tips, the wire, the metal, grinding rocks, all that stuff. And a lot of administrators, because again, my program, I started it, and all these administrators have never been around a welding program at this school. And they were like, wow, why's the budget so big? I'm like, because I'm like you, here's what it costs. Here's the metal. Here's all this stuff. I didn't know it was that expensive. I'm like, yeah, it is. So, but that's part of it. And that's the thing. Everybody hears these big numbers for these big construction jobs, 10 million, 20 million, $1 billion. That's the material. I mean, that costs a lot to build a plan of some type. And especially like you said, since prices started going up, it's going to get really expensive. And I would not want to be the company buying all that stuff. Yeah.
Or the customer paying for the product. Because, the company's not going to take it in the shorts. They're going to pass those expenses on to the customer.
You were talking about you getting certs in your school and everything. We're actually at an AWS accredited test facility. We got that a couple of years ago. And we've actually built in to where our students get the opportunity for 2 certs for each certificate. So our students have the opportunity to come out with 4 AWS certs. And I'm like you, I don't teach to the cert. It just happens to be part of the program. Right. I had the same weld test in my program before the funding started coming in and before it became a test facility. It just so happened that we know, we can get some funding for this. Okay, we'll make it a cert test now. We do exact same tests we did. So I'm like you. I don't train to the certification test. The certification test is part of the program, and that's a big difference there. Because I've seen some programs. All they do is they teach their students, this is what your weld cert's going to be. We're just going to practice this one joint until you get it perfect, and you can pass that, you get that card, and we get our funding for it. And that's not teaching somebody to weld. That's teaching them to take a weld test.
Yep.
And there's a difference.
It's the same thing with like the stupid the Florida State test that all the kids have to take. Like the what the hell is it? My kids have to take it all the time. It's the Florida Standard or whatever test they come out. They come up with a different test every 2 years. It's hard to keep track. But they got to take these tests, and like you find out that the teachers are training and developing and designing the curriculum so that all the students can pass the test, because at the end of the day, if they're an A school, they get more funding from the local government.
Yeah.
So I think it's a crock of shit to do it like that, and it's a disservice to people when they do it like that, because now you're just training for the test. You're not training for the experience they need once they get out of school, or the experience
you're not educating them.
Yeah, there's education is not taking place. You're training them to take a test, and that's it. So I actually just submitted our QA manual to AWS, I think, last week of April or I think it was mid-May. We submitted our stuff for ATF. So I've got everything at the lab. I got the multimeters all calibrated. I got a lockbox for all the testing records, and got in some certified test plates and everything like that with traceability. So I'm just waiting on my audit from AWS. Any day now, there hopefully should be an email that pops up that they've scheduled us for the audit and cash the check and everything. But that's our next step, in addition to opening this new facility, is we're going to become an accredited testing facility. And that's one of the reasons I've had to step out of the classroom, is because I can't train anybody I can't certify anybody that I've trained because of QC4 and QC7 and all that stuff. So I have to take a step back. I've got other instructors in there now. They train and teach the students. And that was kind of kicking the shorts to me, because like I got into welding education because I like teaching welding. I don't like building spreadsheets and PowerPoints and Zoom meetings other than running my podcast. But like, I don't like doing all the administrative stuff. So I've already, I've figured out ways to circumvent that, so I can go in there and I can teach welding safety. I can teach oxy-fuel cutting, carbon arc cutting, plasma arc cutting. I don't test aluminum, so I can train them in aluminum. So I can teach them basically anything that I'm not going to certify them for. So if I'm just going to certify them for SMAW, GMAW, and GTAW, I just won't teach those processes.
Yep.
So it'll work out.
And I'm like you, to me, the relationship with the students, even though you don't want to get too much into their personal lives and become a counselor, a life coach for them, but that relationship, that interaction with the students, and watching that individual grow and learn, and like we talked about, the aha moment, that eureka moment, when they really catch on and you see that fire in their eye, and that's why I do that. And then to see it change their life, and like the office, I said, if I could stay out of the office, it'd be the perfect job.
Yeah.
That office, it'll drain you. But now I'm starting to think, because like I said, I got 3 other people working with me. I'm doing the office work so they can concentrate on the students, because if I didn't do the office work, then they would be distracted, and we'd have 4 people that were part-time, office, part-time instructor. And I don't want that. I want the students to get a fully dedicated, focused instructor. And if I can't be the fully focused one, then I'll take everything else.
Yeah.
So the other guys in the shop, the other instructors, can be fully focused on the students so that they get the training they need. Yeah, and I'm still out there. So I'm like you. I do some of the teaching. I don't do necessarily every single thing, but I'm still in the shop a lot, the hands-on, being in the booth with the students, watching them weld, and like we said before, grabbing that, touching their hands, guiding them, and guiding what they need to do. And that relationship and seeing the students grow is just so fulfilling. And that's the part I really love about it. And that office work would just drain you, dude.
Yeah, it sucks. I'm not a big fan of it, because I had the VP we were talking the other day. She's like, "So how you like the new position?" I was like, I'm going to be honest with you, I hate it. She's like, "What?" And I was like, "I'm not in the lab anymore. Like, I'm not in class." But I get it. I get it. For like, this cohort was really hard on me, because it was like 100% office work. I didn't have time to really pop into the shop, because, like I said, developing an accredited testing facility. I mean, you went through it. That's a lot of freaking work. And I even had help from, I called up Gerald Austin, and he helped me write the QA manual and get me situated. And it was still a lot of work. And then going through, working through grants. We just applied for an AWS grant, and we received the workforce scholarship grant. So I had to work with our scholarship department because I can't submit the grant information and everything because we have a department for that. And if I do it, I get in all kinds of trouble. So I wrote all the paperwork. I got all the quotes and everything, submitted that to them, and then developing the new school that we're going to have over at Midtown Orlando, putting that together, like making sure that I've got the right welding machines, the right booth sizes, all the outlets that I'm going to need for every piece of equipment, buying the equipment, getting 3 quotes and 3 bids on everything.
Oh, yeah.
It's a pain in the ass, but I mean, it was like constant work in the office. So now that all that's done, next cohort, I should be able to get out there and teach and interact with the students a little bit more. And this will be the first term that we have 3 active classes going on.
Wow.
Because I've got two separate facilities. And then the following cohort will have 4 active classes going on. So it's going to be a pretty steady deal.
Yeah. Question for your new facility. How did you set your booths up? What did you come up with? What size are they and how did you do that?
I was given 1,300 square feet. So I got the booths that I got, I want to say they're 6 by 6. And I've got them in just a single line all the way down one wall. The interior section is going to be our fab work. So I got 3 fabrication tables, the chop saw, bandsaw, iron worker, CNC plasma cutter. So I've got like a shop layout area and then all the booths up along the wall. And then I want to do outside where the loading docks are is build kind of like what you have and what Scott Robbie does is like the welding simulators or the welders playgrounds and stuff like that.
Yeah. Where did you put the weld machines?
That's the problem. I'm not done yet, but because they just got the drywall and everything taped off the other day, and they're going through and sanding it. I got Lincoln coming through. They have to put the extractors on a post for us first. So once they get the booths in there and the machines come in, I'm going to figure out exactly how that is going to look. Because the program I have right now, I think the booths they're 4x4, so they're tiny, and the welding machine sits in the booth with the student.
Oof.
I want to be able to
bring a lot of space.
I want to bring the machine outside of the booth. I don't have the space to do like you did, where you have like a 36-inch separation between every other booth to where you can stick your machines in. So I got to figure out exactly because I've only seen photographs of everything. I got to figure out how everything's set up. But we went with the a mix of Lincoln 300Cs. It's that new machine that they came out with. And then we got some Miller 350 MIG runners and then the Dynasties. Because the problem I ran into where I'm at now is if I want to teach everybody a specific process, I can't. I didn't purchase the original equipment for the facility I'm in now. So I only have 4 machines that are capable of doing AC TIG welding. Well, 5, sorry. But I've got 10 booths. So I can only teach 5 students AC TIG welding at a given time. So with this new facility, I want to be able to teach every single process in every booth without having to swap machines out. I hate dragging this machine out and putting this one in here so I can teach you a process. Now with the 300Cs, I can just rotate to that process and be able to do it. And then with the combination of the 2 Miller machines, I'll be able to run everything in that as well, because it's got so many advanced processes in it.
And that's the thing. That's what I try to do as well, is every booth, every process. So you're not limited on how many, like I said, 5 students to this process because that's all the machines you got, or you got to change a bunch of machines out. Then you're not utilizing your time. You're wasting time changing machines. So setting up like you're talking about, where every booth does every process, is what I try to do. So no matter where we're at, how many students, I don't have to worry about, well, which booth are they in? What have I got to do to get it going? And it's more efficient. You get more time actually underneath the hood. You're not trying to which equipment's where. Oh, well, that machine's broken down.
Where's the ground clamp?
One. So, it's just, I think that's the best way to set it up. And it takes some planning. What am I going to be teaching? How do I get that? Which machine can do? Is there a machine that can do all of it? Or do I need 2 machines? Where do I put them? How's this set up with my power requirements for those machines? So as a welding instructor that's building or redoing a weld shop, there's a lot to it than just, okay, I'm going to teach somebody to strike an arc. You really got to think out the whole program and the process and plan out. And that's where I think being organized and having the program set up day by day or week by week, what you're teaching, helps you be organized to when you redo the shop or you do expand to get that next facility, be more efficient. And and that makes it better for the students and easier for the instructors, because you don't have to move all the stuff around and try to problem solve. You just focus on teaching because it's already set up.
And that's kind of one thing that I'll tell my students is a clean shop, or an organized clean shop, is a productive shop. So,
absolutely.
Keep clean up behind you. At the end of the day, I've got we're putting a list inside the booth. So it's like booth cleanup, shop cleanup, and then basically, you know, the expectations. So you can't get away from it. It's right there in your weld booth. You're staring at that wall for 6.5, 7 hours a day. You're going to see everything that needs to be done, and there's like little check boxes. So you know exactly what you need to do when you clean that booth out. And then once you get done cleaning the booth, go clean up the shop. I don't care if you didn't run the grinder today. Go grab a broom and help out. This is a team effort. You guys are a group. You're a team. The product that we're building is skills. Okay, so don't ever be too proud to push a broom. Go get the broom, and like I'll go out there and I'll sweep with them and just kind of lead by example, or just because I'm bored. Like I'm sitting in the shop and it's like, what the hell am I going to do now? Because like I don't like trying to teach from the office. So like I try to stay out of the office as much as possible. Every once in a while, I got to pop in and respond to an email or send something out. You know, then I'm right back in the shop when I was teaching. But yeah, I mean, just like keep everything clean, neat, and organized. Everything has a place. Every place has a thing. I like how you have yours set up. That's kind of, we actually have a storage room in the new facility that we're going to, you know, reorganize everything. And then our current facility, I got access to some new storage cabinets, you know, with like the little PEB bins and everything like that. So I'll be able to have everything locked up right next to the weld classroom, or right next to the weld lab. So consumables, contact tips, diffusers, like everything will be all, you know, right there, right outside the lab. We'll be able to walk around and grab that. Same with the material and everything that they're going to be welding on. Everything's nice, neat, and organized.
Yep. And it helps out, makes it easier for you and the instructor. You know where everything's at. And when you get low on something, you can recognize that. Question for you. Did you read about the straw boss and the tool room attendant? Do you think that's something that would help out? That's
something that would definitely help out. I don't have a tool room, so I can't really do a tool room attendant. So I put a grinder in every booth, and then we have like a community face shield rack. So a lot of students, they prefer to use their welding hood. They get like either the flip up lens or the passive lens, or not the passive lens, regular auto dark lens, so they can do all their grinding and stuff in the booth. But I do make them wear face shields anytime they're running a grinder. They know all the safety aspects of it. But I have set up a shop foreman in the past. So that's something I did when I started teaching, just to give everybody that responsibility. And for the most part, it's nothing other than make sure everybody has what they need. If somebody's having a problem with their machine, I want you to go over there and try and troubleshoot it before you come get me. Don't screw anything up. Don't do anything unsafe. If it's unsafe, just come get me immediately. But then also run cleanup. And then I make them so we put in a gas order every Tuesday for Wednesday delivery. So I make them go through and say, okay, I want you to mark, you know, go through and do a bottle count. And I give them a spreadsheet. You know, here's how many acetylene we have, full and empty, oxygen, full, empty, you know, go through that whole thing. See if we're missing any other materials, we'll get that ordered, and then kind of show them how to, you know, do that whole system. And then every week they swap out. So I'll wait till about 6 or 7 weeks into the program before I start doing that. That way, you know, with the 13 students that I have, everybody gets a shot doing it.
Yeah, I think it worked out good for us because, like I said, again, that leadership aspect of it. And I start my returning students, or my senior students, if you will, as the straw boss the first few weeks before I have any of the new students be so that 6 week lag you're talking about, actually have the returning students do that. That way they can be, and it gives them that mentoring aspect a lot of times, the returning students, because they'll have I always put a new person as a tool room attendant with an experienced student, so that the experienced student has to show them and teach them, and it's not me over their shoulder teaching everything. And so, but it really helps with their leadership. And part of that, and I think I mentioned in the book, is the straw boss has to do a toolbox safety talk every Monday. So at the beginning of the week, I have them printed out. I go over it with them, make sure they're comfortable reading it, because I make them stand up and read it in front of the class, but I make sure they're comfortable doing that. And so they have to do the toolbox safety talk every morning. And then, of course, when they're done, I add a few things to that. And they have to fill out a hot work permit. And then the tool room attendant does a JSA, or job safety analysis. And we actually pass those around the classroom. Everybody reads over it and signs it back, just like on a job site. So they get used to that paperwork. If they go to the construction side, they're used to that paperwork. And because, as you know, in welding, any fabrication, you're going to have a set of prints, you're going to have a package. So you got to be used to looking at paperwork, understand, filling it out, paying attention to it. So I try to put that on the straw boss and the tool room attendant, so that as I rotate them every week, everybody gets the opportunity to do that. Okay. And kind of, again, leads that leadership, gets them a little more comfortable in front of the other students and used to being because maybe they were going to be a foreman one day and they have to do a presentation to the superintendent or the engineer or something. And that way they'll be comfortable doing that. But I think the straw boss and the tool room attendants really helped a lot of the students having beginning the leadership training and see what it's like to be a group leader. And I like it. I think it works out good.
Let me ask you this. One thing we train our students for that I haven't seen any other program do is we actually train them for fire watch. And
we are actually working on, I'm working with our public safety, and we're going to start doing fire extinguisher training this coming semester. So no, we haven't done that yet, but we got it coming up.
Okay.
I noticed that too. My students never used a fire extinguisher. And I'm like, if you're a welder, you're going to catch something on fire.
That's the one thing. Like, so when I was doing ironwork, we had this little apprentice, and like he was new to the job, didn't know how to weld, didn't know how to do anything other than punk bolts and welding rods. So I was like, hey, you're obviously the fire watch because you really can't do anything else because you're a first year apprentice. So here's your bucket, sit on the bucket, watch everybody, watch all the hot spots and the sparks and stuff like that. If the fire gets bigger than a spark, pull the pin, point and squeeze. And he couldn't figure out how to get the fire extinguisher open. So as soon as it as funny as it was, because it was like he was in like full panic mode, he just went from like working at McDonald's 2 weeks ago to, and I don't know where he was working, but like he obviously had never been on an active construction site. So he was like freaking out, couldn't figure out how to get the fire extinguisher open and all this other stuff. So that was one of the things that when I got into teaching, I noticed that we had a fire science program like just on the other side of the campus, and they had come over here come over to the welding program. They're like, hey, we need you to build this this ladder simulator, so that our guys, we can wheel all like 6 different ladders out, and it looks kind of like the side of a fire truck, and they can grab the whichever ladder they need and go. But it's got to be mobile. But then when we need it stationary, it's got to be able to lock in place. So we built them this little frame, and while they were over there, I was like, hey, can you teach my students how to do like fire extinguisher safety? And they're like, oh, we got something better we can do. We can suit them up, and they can actually put out a live fire with a fire extinguisher.
Oh,
so I was like, sweet. So we went over there, and they have a whole class on, here's the difference between your class A's, B's, and C's. Here's the the special chemical fire extinguishers. Here's how you, and the cool thing is that they show you how to put like, they have a dummy made out of old fire hose, and they'll wrap like a kerosene-soaked rag around his leg, and they'll light it on fire, and you have to put it out. And the object that they actually use is a welding jacket because it's durable. So the students were familiar with that, so they got to put out the dummy with a welding jacket. They got to put out the fire with an actual fire extinguisher, and then they got to learn about the different classifications of fires or classifications of fire extinguishers. And that's something that we put like all of our new students through, because what better time to teach them? If I don't want to wait till the moment that there's a fire in the shop and be like, oh, well, the training's next Tuesday. Well, it's a little late for that. So we try to get it done within the first couple of weeks.
And that's what I'm gonna copy on that one, because like I said, I sent an email yesterday to our public safety director going, hey, can we do this? He's like, absolutely. We get everybody back for the fall. Let us know how many, and we'll get that set up. So I'm gonna talk to him and see how much of what you do we can copy, because I'm like you, they're gonna catch something on fire sooner or later. And that's when the fire's starting. It's not when you go, okay, let me read the tag. How does this work? You need to be comfortable with it and know how to do it. So you got it going on. I'm gonna copy that one from you.
It's worked great for us only because we get to, when we go hang out with the firefighters, they're like, hey man, can you guys build this for us, or can you do this for us? So like I've gotten a lot of fabrication projects from the fire program. So we actually built a 2-story Connex, or a 2-story house out of 4 Connex boxes. So we went out there and I showed the students how to shore up the inside of the Connex box, because they had already stacked them one on top of the other, and we had to cut out the 2 side walls of a Connex box. Well, that corrugated metal, that's where all the strength is at. So when you have weight above, you got to figure out. So I showed them how to do temporary shoring, and we actually use legit shoring jacks and everything like that. We cut the wall out, flush cut with oxy-fuel, ground it out, and then put a like a W8 by 30 I-beam. So we had like a 25, it was like a 24, I think it was a 24-foot opening. Ran a 24-foot I-beam in there, ran it up on duct jacks for like duct work. We had 4 of those. So we strategically placed them, cranked this thing up. Everything got lifted up into place, swung 2 columns up underneath it, welded the base plates, welded everything out, released the tension, got rid of everything, cut open windows and doors so they can actually replace the paneling, and it's like this big smoke room. So they have one area that's the whole room is steel from the floor, the ceiling, the sides, and the doors that open behind them. And they'll take a 55-gallon drum and they'll fill it full of straw and particle board and plywood, and they'll just get this place completely smoky. And then they'll send the firefighters in there to go do search and rescue, and they're like, okay, there's two adults in there, there's one child and a dog, go find them. And they have to go through, and they got furniture in there, so it's really cool. We've built a lot of projects for them. So that was one opportunity I had to be able to take the students out to the field, weld off of an engine drive, do work out in the field. Like, yeah, it sucks, it's hot, right? You want to get into construction? Here we go. So I gave them some on-site training. We built a fire prop car where we built like this old, like 1970s style Chevy Cutlass Supreme, that they actually use that, and they can direct where the fire's coming from. So the fire can come out of the tire or the trunk or the inside. So they'll do vehicle rescues with that. So the students, we built that, and then they sent like a flatbed tow truck to come over to our school and then pick it up and then drag it out to theirs. So it's cool because now I can teach fabrication because they're fronting the bill for the material. I'm just providing the labor, and the students get all that experience. Because fabrication is hard to teach.
It is. That's what I would say, that because you can do little small projects in the shop, but that's still not what it's like in the field, because there's so many variables that you cannot replicate in a shop that you'll see in the field in those different projects. Like I said, I mean, using the ductwork lifts to put the beam up, that's not anything you really replicate very often. And getting your students having an opportunity on experience on an actual job in the field is just, I think, invaluable, because they see, okay, all this stuff I've been learning is finally coming together, and now I see why we do the things we do and why the instructor's telling me to do it this way, because now it makes sense. And I think that's one thing that's always great, is if any way you can get them out in the field, do that project out there away from the shop. And one of the things I always like when we do stuff is like, you can't go back to the tool room. If you didn't bring it the first time, you're a couple of miles away, whatever it is. So make sure you bring it, and you got to think, okay, what am I going to be doing? And what's my tool list? Because the tool room's way back yonder.
I try to beat it in their head, because I used to lay at night, and maybe this is just because I'm weird. I used to lay in bed at night and think about, what do I need to put on the truck before we roll out tomorrow? Because I know exactly what we need to do. Okay, so we gotta, we're hanging columns and doing this, so I gotta make sure I get the concrete drill. I gotta make sure that I've got the 3/4 inch bit. I gotta make sure I got the little blower and the epoxy and like all this. Like, I'm making a mental checklist and just playing that through my head over and over again. And then when I get to work the next morning, boom, I get out of the truck and I go to the tool room, get everything I need, load it in the truck, and then you don't forget anything that way. Because I build things in my head. Like if I'd get a set of prints, look at the project, be out there every day. Okay, what are we going to do tomorrow? I'd go home and just mentally build everything in my head, so I knew what I was doing the very next day. Yeah,
and I did the same thing. I actually had my little business for a few years, and that same thing. Okay, what we got? What's the next day? What we're going to be doing? What do we need? What are the parts? What are the pieces? And I'd go in at least 30 minutes, not an hour early before the guys came in, and make sure the truck was ready to go, and make sure we had all the stuff from yesterday off and all the stuff on for that day. And you're talking about building it in your head, look at the prints. I may need some advice on this. How do you teach your students to see the blueprint? Because I think that's one of the hardest things, is for somebody to visualize a 3D picture on looking at a 2-dimension drawing.
Okay. So NCCER Volume 1, they've got some of the projects in there where they teach blueprints. So I've actually built those out of wood. So one of them,
I actually build those out of metal, though.
Okay.
I know what you're talking about, and it's got the little angle and the hole and all that kind of stuff. That's one of our blueprint drawing things. But before they actually build it, I have to do a very detailed class on it, because I still have a lot of students that they don't see it until we put it together.
Right. Well, I took that piece. The one looks like a toilet paper holder. I don't know what. Okay, so I built that out of wood just so I can pass it around the class, because it was like 1/2-inch thick material. So instead of building it out of steel, I just built it out, at home over the weekend. I built it because I was teaching blueprints, and then I'll just lay that up on the board and say, okay, if I lay it flat here, this is the top view. And you can trace everything out with like a black bold marker. So now you can see all the object lines. And if I rotate it this way, it's the front view. And then when I rotate it this way, it's the right side view. So I did it like that. And then for like section views, I took a piece of 4-inch PVC and I glued 2 flanges to the end of it, and then ran it through a saw. So now I can say, okay, here's that piece of pipe, and now I'm going to show you section A-A. And then I just take that piece of pipe and I rotate it to the left, and now they can see the internal components of that pipe. So it's just kind of showing them from examples they can see on paper, showing it in a 2-dimensional way. So I hold it right up against the board, or just hold it in my hands and say, boom, here's that. And I try to make it as dimensionally tolerant as possible.
I like that idea of the PVC, that section AA, because I know exactly which picture you're talking about. And it just took me, I've never been able to kind of figure out how to do that. Because like I said, the most difficult thing I have blueprint wise is getting someone to see the three-dimensional picture in their head. And then from that to that paper drawing. And that's kind of my struggle, is because I can see it. Yeah. I can usually look at it and see it, and I don't understand why they can't. You look at it. This is the top. This is the front. And that's the side. Put it together. There it is. What's the issue, people? Look at it.
That was the thing. When I actually learned how to read blueprints, like I had a foreman that was with me. He's like, I was like, okay, can you teach me how to read blueprints yet? And he's like, no, not yet. Okay, so we're working. Go to the next job. Can you teach me how to read blueprints yet? No, not yet. Okay, go to the next job. He's like, okay, these two buildings are side by side. It was literally, we're building two of the exact same buildings. He's like, I want you to take this set of prints, and I want you to go over there and sit in the shade, and all I want you to do today is watch us work and read the prints. I was like, but I don't know how to read them. He's like, you're going to figure it out. Okay. So I just started going through, and I was like, okay, I watched them lay out all the anchor bolts. I'd follow them around with the prints, watch them lay out all the anchor bolts. So then I got to see, okay, so this big I shape here, this is the top view looking down. It looks like an I-beam. Okay, you're labeling that, C-3 or whatever, column 3. Okay, so these are your frame lines, 1, 2, 3, 4, 5, and then these other ones are A, B, C, D. Okay, and these points line up. So, I mean, it took me being in the field, watching something being erected and put together to understand how to read prints to a better or higher level. And then it just started slowly coming. So one of the things like we're going to start doing that I picked up from my buddy Ryan Eubank is project-based learning. So he's been doing this since like 2009. And it's just very simple sets of blueprints, kind of like Skills USA competitions and stuff like that. You're familiar with those. Bring those prints into the classroom, and you can tack up a mock-up if you want, just to show them what it's supposed to look like when it's done, but you don't have the dimensions on there. But yeah, give them the sheet, give them the materials and stuff, or have them cut the materials out on their own and say, okay, you guys have 2 days to build this. On your mark, get set, go. Yeah. But we have some that we go through and just kind of, okay, here's on the first one, this is how we do it step by step. So I'm going to lay out these lines right here, and I put an X over here because that's the side the plate's going to go on, kind of like a wall stud, and just kind of go through all that.
I do a lot. I emphasize prints a lot, and of course, I go through the NCCR, and there's a couple chapters there. But I do a lot of ISO drawings on pipe because, again, pipe guy. So that's what I focused a lot of mine on, was having them see the 3-dimension ISO drawing. And we've gotten PVC pipe, and we would put something together with PVC pipe, and then show them, okay, this is what the drawing is. Here it is with pipe. And then we'd also put some stuff together with pipe and have them draw it out. Now that's funny. Having a student draw a blueprint, that gets funny. Yeah. But we do blueprint stuff, and I don't want to seem like I don't, but we do. But I, again, focus on the ISOs because we're really focused on the pipe, so they can see how that the ISO drawing is 2-dimensional, represents that 3D pipe system, and they get that pretty good. But having that picture, like the ones you're talking about in the book, that having that actual picture where there's the cutaways and section views, that's where I haven't quite got them to wrap their head around that one. And that's the tough one for me.
So I had my new instructor, Malachi, he would teach the day class. He kind of took my spot when I entered the office or the management area. He came up with a really cool project. So he doesn't swear at all, and swearing is not allowed in the shop. So he, instead of a swear jar, he made a swear bar, and it's a pull-up bar. Okay. So if they swear, they got to do X amount of pull-ups or whatever. And they all agree to it because it's all in good fun. So if you don't agree to it, just don't cuss. But if you do cuss and you agree to it, you're going to pay the price. And he'll get out there and do pull-ups with him, just the same if he slips up. But what he had him do is they built the pull-up bar. And then once it was done, he's like, okay, I want you guys to put this on a blueprint. So spec it out, figure out where all we put the welds, what size welds we put in there, what type of weld we put in there. And you guys are going to draw, a set of prints. So you're going to have the top view, front view, right side view, and then you're going to do an isometric. And so I think they had like 1 week to complete it. And this is already after they kind of went through blueprints and stuff like that. So they had to label everything out, dimension it correctly, using all their extension lines, dimension lines, and, section lines, everything that they needed to, and build the pull-up bar on paper. So I thought that was pretty neat. Is like, okay, we've already have an object that's built, have them draw the prints. That's one thing that I've never done with the students. I've already shown them, okay, here's the prints. This is how we built the project. Yeah. And like, I know how to do it really well because I went through technical drawing to where I had to draw the object, not build it. So it makes sense to me because I've seen it on paper thousands of times, and it makes sense because I know all the rules. But if you don't know that stuff, just take the fabrication table in your shop and have them go through and actually draw it, dimension it, figure out what weld symbols, location, what side the weld's actually going to go on, and kind of make it as accurate as possible, and then grade them with that.
And they got to use a tape measure to come out with the measurements.
They have to come out and they have to double check all the measurements because they don't know what it is. We built it. We don't remember the dimensions. So, go ahead.
What's funny is we don't allow cussing in our shop either.
Right.
Yeah, and that's one of the first rules we have on our rule and conduct sheet is there's no cussing. And a couple of reasons why. I mean, Christian guy really don't want to hear it, but we have a lot of tours come through. Yeah. I mean, I've had the president of the college come in with county commissioners just pop in. I mean, and one of the students like, hey, there's some people here in suits and dresses and stuff. I'm like, okay, whatever. And I'm sweating. I'm out there and dirty, and I walk up. President of the college, 2 county commissioners, and we used to be a state senator. And oh yeah, we were doing a tour. We just wanted to see what you got going on, Scotty. And I'm like, and the last thing I want to do was have somebody drop a bunch of F-bombs while they're standing there and have to explain that. But and that changed the atmosphere too. Really, to me, makes a more professional atmosphere because students have to kind of look at their conduct and go, you're not just in there doing whatever, running around. So they kind of got to be professional. And so I've never heard another shop have the same rule as that. And that's kind of cool.
It was pretty neat when he implemented it because I gotta admit, like, I'm pretty lax because I'm a jarhead and, aside from that, an iron worker. So like every once in a while I get some stuff that slips, but it's like I'm not shouting it at the top of my lungs. But I've noticed once I start doing it, then the students start doing it. It's like they're like little parrots, but they don't have a volume adjustment on them. So, and it's like you said, like I've had the president of the college walk through, and it's like that now is not the time and place to be. And keep it down. We got a class next door. So I think implementing no cuss words in the shop that's going in the syllabus for this cohort coming up. And that's like you said, it's a more professional environment. Now we actually have to think and use other words. So now we're going to expand our vocabulary. Now we're going to expand the vocabulary a little bit. But no, it's been pretty neat. And I thought it was a really good assignment for them to have to kind of essentially reverse engineer and draw something up that they've actually built versus, building it from the prints. And I've had students do it before in the past, but not to that degree. So when they built that, the fire rescue prop, I had them go through and say, okay, we need a design. So I want you guys to design it. And I want you to dimension it out. So we built a set of prints before we built the object. Okay, now that we have this all drawn out and everything, what material are we going to use? Okay, 2x2 square tubing and 1/4-inch plate. Okay, so how many linear feet of the square tubing are we going to need for that entire project? How much sheet metal are we going to need for that entire project? What consumables? How many grinding discs are we going to go through? How are you guys going to, cut the material? What else are we going to add to it? You want to put some flair to it? We got to put a bumper on there. So, they had to figure all that stuff out and draw it out, and they did pretty good. And it worked out really great.
We've done something like that on our playground. We have a tank, and we have it's got 2 outlets on it, and we have a piping system we have the students build. And I know the dimensions because we built it for several years, but we have the same thing. Okay, we got to go from here to here. You got 2 90s and a 45. What size pipe is it? How long does it need to be? How far do we have to come out to go around the tank? So we do something similar to like that. But I said, again, I focus on the pipe. I'm probably going to wind up doing one of those. I got a cut table that we use. Probably have my students draw the blueprint of that because it's actually got slits in it, slats in it for putting the metal on. So they have to measure what the distance is between the slats kind of stuff. So I've done it with the piping. I think now I just put it in with the structural side of it. So that'll help them with the blueprints and the blueprint reading and the measurement as well. There's so many things they get from that activity.
I'll have to, I'll get your email and then I'll shoot you over. I got just a set of basic prints because I'm starting to pull stuff together. And now I've got one of the other instructors who's really proficient with SolidWorks. That's been my biggest downfall is like, I can draw it on a drafting table. But like outside of running CAD, like I used to be really good at CAD back in like 2014, but I haven't used it since. And it's a very powerful tool. And I'd essentially have to relearn it again. So I have another instructor. He's really proficient in SolidWorks. He teaches our mechatronics program. And he's offered to kind of like draw up our prints. So I'm just going to take little projects. I'll weld them up, tack them up, and give them to him. And he can dimension them. And, I'll tell him exactly what weld sizes need to be where. And then he can draw it up. And then I can give that to the students as another project. But yeah, if you want, I think I've got like 4 or 5 prints or something. I can shoot you an email, and it's got.
Oh yeah,
and it's just
that'd be great.
It's just simple little stuff, that it takes maybe 5 or 6 coupons to put together, but it's done in a certain configuration, and you get a whole dimensional tolerance. You can add air inlets, so you can actually pressurize the vessel and then put it in the quench tank and see if it leaks. So it's actually pretty neat.
Yeah, I'd love to have those, man. I'd appreciate it if you do that. Yeah,
no, definitely. Well, cool, man. It's I really appreciate you taking the time to come out to the podcast and chat with us and everything, kind of explain about your school a little bit. I always like talking to other welding instructors to figure out, what's working in your program, what can I put in my program, just kind of share ideas, share experiences. It seems like we have a lot of the similar situations that happen in the class and how we run the program and the success stories that come out of it. So it's really, really neat having you on there, and I highly recommend anybody that teaches welding, go on Amazon and pick up Scottie's book, How I Teach Welding, Professional Advice on Implementing a Welding Program. It's a short read. I think it was about 80, 95
106.
pages? 106 with the drawings and stuff. So
with the pictures, it gets to be 106 pages.
With the pictures. No, it's a great book, man. Like I said, about halfway through, I was like, damn, it's like I'm reading my autobiography. So it's really good. I love what you've done with it. I'd be interested in coming up to your school at one point and taking a tour of it and see how you run things up there. And if you ever get down this way, the invitation's open.
Well, man, I appreciate you having me on, taking the time to talk with me, and you are welcome anytime. Like I said, we're up here at Fort Walton, Destin area. So if you ever come up into the Panhandle, man, I'd love to show you around what we got. And my wife has told me that we're going to take my granddaughter to Orlando to Walt Disney World. So when we do that, I'll be in your neck of the woods. I'll definitely look you up and come down there and see what you got going.
Yeah, hit me up, man.
But I appreciate it, man. And yeah, that book was just the stuff. It's what I do. It's nothing, no research to it. It's just the things I've implemented. I see that work, and hoping maybe somebody can read something, pick up on something, may help them in some way to, help their students learn so that the students can be successful. And anything in that book, anybody's welcome to use or copy or change or implement in any way they want to.
Yeah, I'm probably gonna pick up 2 more copies because I don't want to give this one away, but I'm gonna have give each one of my instructors one. Like I said, it's not a difficult read at all. I think and I'm a slow reader. I read it in 2 days, and it reads very fluid. And it makes a lot of sense.
I appreciate it, man. Thank you.
Yeah. All right, ladies and gentlemen, that is all I have for you this week. Thanks again for tuning in. I really appreciate the support you all show me. If you're enjoying the episode and finding value in it, please share it with a friend or coworker that you think would also enjoy it. Stay safe out there, and until next time, make every weld better than your last.